Okay, thank you. Good morning to everyone. We need to start now. We are starting with another talk related to artificial intelligence with applications like in eyewear. So I would like to invite Professor Dr. Arturas Seraskis, who is the head of the Department of Electronic Engineering in Vilnius Gediminas Technical University. For me, it's easier to say Vilnius Tech. He's full professor in this department. His work is includes artificial intelligence, and the title of his talk will be Innovation in Eyewear, Automating Virtual Try-ons with Artificial Intelligence. So it's one of the applications that he's going to present related to AI. So the floor is yours for the next 45 minutes, and thank you very much for your time and your contribution.
Thank you. Thank you. So in the beginning, it works very well. I would like to introduce myself a little bit, talking about shortly about the previous projects that I had in the last 20 years, which actually bring me to the AI applications in eyewear also. So first of all, my background is electronics engineering. So one noticeable result of our projects was autonomous speech-driven controller, which is reacting on single word commands without internet connection and based on embedded systems. Then my PhD research was related to the two-dimensional electrophoresis image matching, and the aim was to find the differences between protein spots and see how much one or another type of the protein grows or decreases during the cancer treatment. So they were doing it manually, visually, and when you have 10,000 spots to compare, it is also impossible to make no mistakes. Then we had different applications which were interesting for us as a scientist, as a researchers, and some also interested for the students I was supervising. So one research was related to the eye strain and eye fatigue analysis and how we can measure it when we wear 3D glasses or virtual reality glasses. Then when understood that the signals we can measure from IIG actually shows nothing very detailed about what we are thinking. But in this image, of course, I have single sensor, but if we even put more, this spring I saw one paper where the scientist said, look, the artificial intelligence can draw the scene of what are you thinking when you wear those IAG sensors. So when I look deeply in this paper, nothing actually you can get from those signals in such detail, because if you will build a system which will draw or animate anything which is most expectable at current moment, what are you thinking about, then you will get the same result without any sensors. So another thing which we discovered interesting, that when we track the gaze point of the human and we draw the attention maps on the images when you look, then finally the result is very personal information, because there is a big difference in the crowd when we look at the people. When the guys looks and the girls looks, there are different spots which are more active, and sometimes these spots are so very private, you know. Another application of AI which we also tested was the sound source direction estimation, and even we can calculate the distance to the sound source, because the AI models, the big AI models, they can learn the acoustics in the room, because in each room the acoustics is very complicated to model, because we have many objects different materials. Even if you know the material, put the coefficient of the absorbance and reflection on professional software like ATHENA, it actually models totally different situation that you get when you're recording. So there are also another topic we touched was related to sepsis prediction. So we participated in the challenge organized by MIT in 2019. Well, the motivation is high because we have one death every 3.5 seconds. And the aim was to predict sepsis 6 hours before it was diagnosed. So the first attempt, we said that, okay, we will take the big AI model, put data from 50,000 patients, and this model will somehow learn to detect sepsis and everything will work because the AI models are very good, etc. And then we've got the result. The algorithm shows, okay, I am able to classify sepsis in 98% accuracy, very well. Then we looked at the model and understood that model says no sepsis for all patients because in the data set, the amount of patients with sepsis was only 2%. So then, of course, we need to do some data analysis, balancing, another thing to make it work. But there are many parameters we can measure in intensive care unit. You don't know which parameter is more important, which is less. But finally, the more time you spend in ICU, the higher risk you will get sepsis, actually. So, of course, we presented the model, two model approach for sepsis prediction. Our solution was about in the middle of the place 70 from 150 selected for conference. But actually, the accuracy of prediction for all participants in the challenge was about 82, 87 for the data from 2 hospitals. And when we tested all the models on the data from the hospital number 3, which was not used for training the models, then we saw that the accuracy drops. That means that actually the sepsis occurrence depends much on the personnel which we has and the treatment which we has in the hospitals. But what is more scary for us in Lithuania when I said that, you know, I have a solution, we can predict some sepsis in advance and you can prepare treatment, etc. The doctor says if you start treatment and you will not get the diagnosis of the sepsis, so those expenses will be not compensated. Okay, so no reason to detect anything in practice. Okay, so that was sad story part. Next, we had one contract with the companies in the industry, and they said that we need to create a
Severe
system.
weather conditions is one of the main cause of traffic accidents. For this reason, we have
that
introduced a
detects
16-bit thermal
on the
dataset containing
road.
an extensive variety of fine-grained annotated images recorded in 4 biggest European Union countries.
Okay, I will skip that too loud, but detects pedestrians in advance, 300 meters, not 50 meters as all detectors does, because if the pedestrian is on the road and only 50 meters remains, you'll know that who dies actually in the accident. But if you have 300 meters, then the pedestrian has a chance. Then we saw that the classical models, machine vision models, which scans image, sliding the windows, they are making classification with such resolution. And even human cannot detect is it pedestrian or not. But what's interesting for the current bigger models of AI, they can take the full image as input and learn the context. Learn the context actually as we do, because we recognize the road, that this is the edge of the road and the pavement and etc. And probably this bright light is the pedestrian. So this is what actually the AI models now do similar to humans and get the similar accuracy. But when you build a system, a prototype, and start to run it in the real situation, then you got the false detection, and it requires expand dataset. The next image, you've got the pedestrian detection on road signs, again, expand dataset to make it more robust, and etc. Okay. Were we original in our approach? Not much, because we had an Autoliv system which sells their solution to BMW and Daimler for night vision. But we found their paper on the past system, which was based on machine vision, and they talk about 8 years of feature extraction to build a system which still doesn't work in a robust way and has false detection. So when I present this fact to one company CIO 3 weeks ago, he said, I had an accident 2 years ago with an animal with my new Mercedes-Benz, and the car didn't detect those animals, unfortunately. So we didn't build a system which is robust enough, but we are not the situation requires more solutions. And if you want to build something like that, we found the Ada Sky startup from Israel. Well, they've got 20 million investment for doing AI-based pedestrian detection at the same time as us. So we got about 10,000 times less investment. But the approach is the same. You need data, labeling. So what they did, we did the same. But the problem with AI is the quality of data, and you cannot trust anyone but yourself or your wife, because you should be very motivated to make it on the high level of trust, because if you didn't mark this pedestrian in your image, so you will train the model not to detect this pedestrian in the image. The model will know that it should detect this one and not detect this one. So the quality of data is so important that you cannot give for students the task for labeling, because they have no motivation to do it on a high level of quality. So these are the challenges. And when we traveled through the university, I met my colleagues from biomechanical department. They say, well, we have some connections with our hospitals, and they have system for tracking human, and they are able to measure all the movements, angles, and pose estimation in real time. If you put landmarks on you, and the system costs about 100,000 euros, and actually one measurement for the rehabilitation takes 45 minutes. So actually no one uses it because it takes too much time, it requires calibration every time, but we thought that probably we can make it more simple, cheap, 100,000 times, no, maybe 100 times. If we use the AI models, which are big and can predict the skeleton movements post-estimation. And we succeeded. So this is solution of my PhD student, Ervinas. And we see that simple camera taking videos from the front can predict the skeleton. And if we add another camera, so it is more precise, really enough precise for the doctor to make it some decisions about the progress of rehabilitation. So it is 2 cameras only, gaming computer, and that's it. And you don't need a special room for that, you just put it anywhere. So this is what actually changes the application of AI models. So actually, as electronics engineer, we want to make it work in embedded system. This is the no. This is the video from the exhibition we made last year for demonstrating working it live. So as you can see, the gaming computer is needed for visualization, but processing is in a embedded system. Last year, we have different application, totally different, because the motivation was the high prices of electricity in Lithuania also. And we thought, okay, the wind farm will be built in our sea, Baltic Sea also. We need some predictive maintenance. We also used the big model. We thought that if we give enough data, it will learn everything automatically. It doesn't work actually. But we found that a simple solution of anomaly detection, when you can model the exact changes of the temperature, then if your model predicts changes of the temperature accordingly to the situation, environment, and etc., you can detect the situation when the temperature is not changing accordingly to the usual usual model, and then 37 days before the failure, we can detect the failure of the gearbox in the wind farm. But when we showed our solution for the companies which owns the wind farm, they say, okay, Arturas, everything is good, but we don't need this solution. We need to predict how much electricity my wind farm will make next day for Nord Pool. Because if we fail, it can cost 100,000 euros per month to balance the situation. Then we made a solution for predicting how much electricity the wind farm will make in 24 hours in advance. And we are doing about 82–87%. And have a system which is really competitive to the worldwide commercial product, which they say that it predicts 90% on historical data. Also, even before the pandemic, we got some funding for the research on virtual reality solutions and related things, and we want to automate some pipelines for those, because it is very time-consuming to process scanned point clouds, rendering, and etc. We made some prototypes without particular application in mind, or without contracts with the companies. But then the pandemic came, and the head of one startup called me and said, Arturas, you are doing something with image recognition. We need to create a system for eyewear for virtual try-on. Well, even if we have some solution available on the market, they have one small drawback, which doesn't let us to sell lenses for eyeglasses frames. When I told that I'm for my colleague from Technical University Delft that we are working on virtual try-on, he said, Arturas, you know, at least 10,000 universities are in the world. Exactly, I think maybe 20,000. But now, in 2021, I think in each university you will find a group of researchers that are working on virtual try-on applications. Well, so it seems that you cannot be competitive if so many researchers work more or less on the same direction. But in our university, that was our group. So the exact challenge we had is that you can wear virtually those eyewears, glasses, and from the electronic shop. But when you order those, you see that these does not fit. Why? Because the technology do not know the exact dimensions of your face in the camera. So we need a solution to measure how many parts of the millimeter the single pixel has for particular image. And then I will tell more detail a little bit later. Then we start to analyze how actually things work and how we can do it in current state of the art. So we found some good AI models, media pipe models, which do face landmark recognition tracking in real time. So I just tested it yesterday again. And it predicts actually the position of your eyes and etc. And we can use it for person identification if we want. To measure something, for example, the distance between pupillar distance, then the precision should be in the range of 1 millimeter. Okay, so if we've got iPhone with a Face ID, then we've got a lot, thousands of rays of infrared analyzed, and we can get the landmarks and estimate the PD distance without problems because we've got the scale. So as you can see, I'm at home because of pandemia in 21, and I understood that even I am able to run to create an application if I have iPhone in 10 minutes, and this application works in the same precision as the commercial application I can get from App Store. But the uncertainty we got actually is 3 millimeters, more or less. So even this solution is not good. And when they said that the CEO of the startup says, Arturas, we need, without any Face ID cameras, for simple Android camera, we need to measure the pupillar distance with the precision of single millimeter. I said, it is not possible. Actually, we cannot make it. But they give us funding. We've got the challenge. And we made it, actually. Talking about the virtual try-ons, we have many startups, even successful, well-known. Many of these for clothing, even makeup, everything seems working in real time. Even we have the competitor Ditto for eyewear. But actually, to get the scale of the face, you need to show your credit card here in front of the camera. So finding customers which wants to show its credit card for the camera, it is quite challenging, because I don't want my credit card to be filmed and going somewhere else. That is why we needed to create a solution without any credit cameras, without any markers that customers need to print. It is actually impossible. But the idea of the application is that you can buy something at home, you can order, especially for those who would not like many conversation with people, introverts, they want to sell everything without contact with the other persons. So we have part of the market which is not covered yet. And for the retailers, what is interesting? Of course, some less workload for the persons in the optical shops. But when we did a solution, what is more interesting for the retailers was how many conversions each optics make per day, how many customers they passes our system, and not actually the precision of measurement pupillar distance. So, but anyway, we've got a solution in the startup OculFit, and we made it possible to calculate pupillar distance with the uncertainty of 1 millimeter. We can measure the optical height and other additional parameters without any markers, special markers, but you need eyeglasses frames to put on, and also enter two numbers which you can find on almost all eyeglasses frames. It is the lens width and the bridge width. So we need a machine learning or a deep learning model for iris detection, another model for detection of the edges of the eyeglasses lenses. And that's it. It works, and the precision is good. Of course, when are we testing now in Lithuania and in Denmark, we've got many new images from real-life applications. You see that probably sometimes the iris is not detectable even by you, but the algorithm can predict the position, and when we train with more examples, the precision increases, and actually this is what you can get. So actually now, using our solution, you can order lenses even of 2 layers sitting at home, or actually with the optics without those manual marking of the points. So the next thing, okay, if I can get the scale of the face, I can put on that virtual try-on glasses and see how it fits on my face. But now the question is where I will get those models, three-dimensional models of my eyeglasses frames, because in eShop I have product images and about 4,000 of frames available, and every half year new models appear. So we know one startup in Europe, I think in France, you need to send the physical those glasses to them, then they scan, make 3D model of high quality, but it costs about 30 or 35 euros per item. So for small optics, it's not the case. Every year you should send some new amount of glasses, and it's not convenient actually. So they say, Arturas, we need a solution to make a 3D model when we have only 3 product images. One from the front, one from the corner, and one from the side. Okay, so I said it is impossible, of course. Because we tested, well, probably if you have the same object from different angles, you can use the classical photogrammetry, feature point extraction and matching. And when you take those algorithms and run on eyeglasses frame, you see that it is nothing you can do with that, because feature extraction, which is good for those CT 3D maps and etc., doesn't work on these frames. Then we look what we can find in the internet about state of the art of the models, which are trying to predict the 3D model from single image. We found a solution, and it actually takes a single image of the chair, and if you train your model on the big amount of examples, the model learns to predict the actual three-dimensional model. It was very surprising for me to see this quality, but sometimes the model fails on the unseen shapes or images. But actually, this is not what we need for eyewear industry, because the precision, well, is not sufficient. Then we look at other solutions when we've got the face 3D mask from single image. So it actually predicts the position of the point in the cube from a single image in the input. But the resolution is too small for eyewear industry, and we skip this approach also. But then we found that 3D face generation from the single image could be made from by using 3D morphable models, but you need just a template model, some universal head model, and then try to map the image and predict how to transform this model, similar as we can see in deepfakes video. Then we can make a head, and the question is, can we transfer this idea to our eyewear? Well, if we use the face, then we have models which detects 468 landmarks on the face, and we can transform that face and the measurable model transfer and fit on these landmarks. But we have no model for the eyewear industry. Then we do the classical approach, step by step, adding different machine learning models and even image pre-processing tasks, starting from extracting the foreground on synthetic models. Then this trained model is tested on our real product images. We have some still challenges to be solved. But then, making a pipeline of image processing steps, we were able to generate model of the solid color, but only for the front part. So I was thinking about how to make it about 3-4 months and write the code in one night, as usual, like student actually. And then we can put at least the front of the glasses for virtual try-on. So this is the demonstration actually of batch processing, because the idea is that I process all my product images which I have in my electronic shop and get the 3D models. But now the quality is not full. I have no full frame yet. I need to add more details, temples and etc. Because there are small elements of the eyeglasses frames which should be also taken into account, so we need to use additional model which classifies the types of eyeglasses frames and etc. So we asked for European Union 1.5 million funding for that. Didn't get it yet, but I hope in the near future we will succeed. So thank you. If you have some questions, I'm here.
Are there any questions? I have some.
Okay.
All right. So the first thing I would like to ask you, you showed the picture and you spoke about data quality. So there were pedestrians, and you said, like, if we don't train our system in order to show that the pedestrian is there, the system will never learn that the pedestrian was there.
Yes, it will try to learn, not to detect it. actually. So it will have challenge because some pedestrians should be detected, some not, and then the model is confused. So we noticed that on Kai's data set from China, it consisted of 50,000 of images. And we trained our model and see that the accuracy is not more than 87, 88%. And we start to search the reason why. Then we found that errors in labeling. And what we did actually in 2020, we finished collecting the data set of 200,000 images labeled, collected in winter, in snow, in rain, in Lithuania, Poland, in Denmark, in Germany. And those labeled images was in different several weather conditions, and it led us to build a pedestrian detector, which in 2020 was the best in the world, at least for 3 months, when we published our paper in IEEE Access, and then, of course, we...
So what are the parameters that define the quality of a data? Is the number? Is like the technology that you are using? What are the parameters that they can determine or they can help engineers to define high quality data? For your application?
For my application is actually hard to find the parameters because we also had to make some kind of automated quality control, but this quality control is also based on AI models, which are trained on labeled data, and well, it's hard actually to measure it.
If it is hard, how you can say it's high quality or low quality?
You need to check it visually.
Okay, so it's like by trial.
Yeah.
All right.
Yeah. Of course, if you have 200,000 examples labeled, you can run your model, which was trained on other data, and you can measure it.
Because precisely. For me, it seemed from your presentation that technology also plays an important role regarding the resolution. Because you saw another transparency that you said like, oh, the resolution here was low, so the system did not perform as supposed to perform. So it seems to me that the resolution of the cameras that you are using also define the quality of data, let's say, apart of the number.
Yes, but the problem of such type of the camera that we cannot get the resolution high enough. Well, currently, if you want a commercially reliable camera, which costs not 12,000 euro, then you are limited to 400, 500 lines of resolution, and that's it.
Correct. And I would like to also to ask you, because it was a very good point what you mentioned regarding the artificial intelligence and the distance between the frame, if I understood well, and what kind of lens you should use. Am I right?
Yeah.
All right. So, I mean, when I'm going to the ophthalmologist, they are using a glass frame that, you know, the distance, it seems to me as a customer that is very close to this distance that I'm using. Of course, I have faced, you know, the problem that you mentioned, that I'm buying glasses and, yeah, I mean, it's not, you know, the performance of my eye performance is not as expected. And probably, you know, they need the correction. But what is the extra thing? Why, you know, to the EU to pay such an amount of money if, you know, this kind of distance is taken into the account during the examination by the ophthalmologist?
Actually, for each eyeglasses frames, the distance is a little bit different. So we are making a system which is more easy to use without adding extra parts on the frames, and is quick to use. So we put actually our tablet computer in each optics. They put few images only, and they got information, well, results, which actually, when we saw, is even with less uncertainty when the optical professionals do in their own way previously. Of course, if not using that big expensive measuring.
So do you think, as a technologist and the person that you lead the innovation, that virtual reality or augmented reality can replace the ophthalmologist? Because if you can have, such a system and you can calculate this, you can replace the lenses, and this examination can happen by anyone everywhere.
Well, we develop it not to replace, but actually to make things, tools more simple to use, and also as a separate part is to measure how many people they measure per day, because all the information, all the measurement goes to the data set, and we know exactly how much time they spend, what is the conversion rate. And this is even more important for the retailers than the exact measurement.
It's also a training tool.
Please?
Yeah. Yes.
It also can be, I also don't believe that it will replace, but it's a training tool for
Yes.
a new professionals. And also, I think there is a factor, someone who has glasses and goes, it has a human factor to it. This whole examination, maybe it's an assistive technology, but to replace some people, they will be afraid to do that because your eye is like when you do iris biometric, people don't want to put their eyes inside.
Closer to the microphone, please, because you should follow
The orders.
Thank you for your presentation. Is it possible to ask you for details? As I understood, you use some image recognition techniques, yeah? Is it convolutional neural network, or what type of technique? Maybe you use you mentioned data set of 15,000 images, yeah? Was enough? Did you use transfer learning? And if you used, from what basic model you transfer learn your model on those 15,000 images and so on?
Well, if we talk about the pedestrian detection, then we actually started from that 50,000 data set from China, and we made actually our own, the bigger one. And then we tested first the model which was trained on ImageNet for those far infrared images. And it is, of course, better than training from the beginning, but actually the precision was very low. So what we did, actually, we passed first labeling of 10,000 images, transfer learning on the model, pre-trained model, and then the next labeling is made by our model, pre-labeling, and then we increase and iterate that every time. So after some tens of thousands of images, you've got less work to annotate.
So you mean reinforced learning, yeah?
Well, yes, but it's like manual.
Thank you.
So I have another one. Actually, I have two. A very fast one. You mentioned, what is sepsis? I don't know what is sepsis.
I'd say.
Let me ask. Who knows what is sepsis? Sepsis. Yeah. So in order to give the answer fast.
You don't know what is sepsis? Is when you have an infection? Yeah. No?
Blood infection, yeah.
Sepsis. Okay, all right. Thank you. But my question was not that. It is like you saw a system, a wind turbine, and you mentioned that through the motion of the propels, you can detect, changes in the environment, or probably mechanical problems that probably the turbine has.
Yes.
And you had a graph. So how do you know, or your system, how can distinguish that this is not a problem of the environment, probably of the flow of the air, of temperature changes that affects the airflow, or it's a mechanical problem? So from this kind of graph that you saw, how you can distinguish what is the reason of this signal? Because, for example, in Navy or in the shipping industry, in order to identify, using artificial intelligence, mechanical problems with the propel, they measure the frequency. So through the frequency of the machine, they can detect or they can predict that there is a problem with the machine. So in this case, how do you back up this measurement? What is the reason of this measurement?
Well, actually, the solution is really very simple, and I think that when I talk with the CIO of different companies and the industry, there are still so many room for using the decision. But the idea is that if I feel that the temperature of the gearbox oil will be higher if there is mechanical problem. But the problem is that depending on the state,
On the frequency?
on the frequency, on the intensity, on the temperature of the environment, that temperature could be at different levels actually, and I cannot select the threshold which is fixed. So I need to find the machine learning model which is flexible enough to model external environment like wind speed, external temperature, and model what should be the temperature of the gearbox oil. And then if all environment measurements still persist and I predict what is the temperature and measure the exact temperature, I get the quite big differences.
So you have backup measurements at the same time. This is not the
Yes.
only measurement
Yes,
because you
yes,
saw.
yes.
Okay, so
And
it's
our
clear.
colleagues also did something with vibrations. So for the engine, car engine, they only measuring the amount, the level of vibration, they can predict what is the exhaust system, the gases concentration. Actually, even that.
Now it's clear.
So it is very interesting because many applications. I had from Italy the PhD intern last year, and he was working for the company which builds some pneumatic tools, the big ones, which works in China and Australia, and they had no information about which part of their machine, how long it actually takes before it fails. And they had no information, and that numbers they took from somewhere else. And only last year they start to measure and collect the data, because when it fails, it stops for 2 months, so it is disaster. But so simple solution from machine learning, but not introduced in the industry, and that's.
So artificial intelligence also through these measurements and the backup measurements that you are taking can predict if a failure will come.
Yes, and the model is so simple from the mathematical perspective that I'm surprised that they are still not there yet.
Yeah.
Why?
The same happened with the lasers. Lasers invented in 1963, and the people wonder why lasers they have not been invented much earlier. It was a simple idea that no one thought.
When we talk with the professionals in the lasers industry in Lithuania, so the professional, they work for more than 20 years on laser developing, but they cannot explain how and why they did so or other solution.
So, is there any other question? Are there any questions? Okay, so thank you very much again.
Thank you very much.
Do we need a 5 minutes break and then come back, or you would like to continue immediately? Directly? All right, let's have a 5 minutes break and come back. Andreas? So, we start. So, in the program supposed to be a colleague from Poland, but this colleague could not come. She informed us last night, so I have prepared something in order to replace her. So I'm going to discuss with you about the activities, of the Athena European University and how we can organize blended intensive programs and how you can organize various things. So I'm going to present you the activities that we are doing in education and research, our relations with industry, and what we would like to do in the next 4 years. So in order, because yesterday you said that we would like to introduce each other. So my name is Kostas. My PhD and whatever I'm doing has to do with lasers and materials. And I have my PhD from the University of St. Andrews in Scotland. Unfortunately, there are not too many Scottish people around us, but this is... Siga, you should be focused instead of writing emails. And, all right. So this is what I'm doing, and this is a video about Athena, but I'm going to skip it in order to move to the real actions. So I will present you what are the principles of the European University. As I told you, there are 50 of them. They would like to become 60. It's going to be very competitive the next call because only 10 European University Alliances are going to be granted. And you need to score more than 85 points, which means that you should have a very strong background, what you have done, in order to establish something that is going to be competitive. I will present you the Athena Consortium, the Athena highlights, what we have done until now, the Athena next vision, sorry, I prepared this last night, and the conclusions. And about the vision of Athena is very much linked with the discussion and the presentations that has been made, from all of you. So the principles of Athena include, of course, all the priorities of the European Commission. We should be inclusive, which means that our activities should include everyone, and you will see our activities include everyone. So, for example, in education, we don't have only face-to-face activities, but we have also online activities. We don't present, things synchronously, but we present things asynchronously as well. We organize short mobilities for people that, they are hesitating to mobilize in order to have a very short experience in order to encourage them to continue. Whatever we have is shared at a level, because it was like a 3-year project and we continue right now. And also, whatever we are doing is like in the languages that everyone can use. So, English right now is the dominant language of the alliance. But there are other alliances that Spanish is like the dominant language because the people, they have a focus in Latin America and they involve other partners from Spain. Market and industry needs is something very important for all the alliances, and the society needs. All the alliances, they should address societies. So the universities, they are becoming not only to addressing the market needs and what kind of changes and transformations of the curricula should happen based on the market needs, but also we would like to work in a local level, and which means in 9 cities in our case, as solution providers of society needs. So we would like, this is the next step, to invite the mayors, the city halls, in order to present their needs, and the universities to provide the solutions. So we are moving, the Athena Consortium is this one for the moment. We are 9 universities, non-centralized. We don't have a university in any city capital. You can see over there University of Cusano in Roma, but they are not anymore parts of our alliance. 4 internal regions, okay? But we have all the associations of the Brazilian universities. We have a very big association with African universities. We have Carinthia University of Applied Sciences that now is on the process to become a full member. And we have the collaboration with Ukraine, of course, in order to facilitate the continuation of their programs. In order to apply for Athena, it's like a straightforward process, but it's going to be a slow process because the rectors, they should decide. And, you know, this takes time. We have 4 research centers, 2 national authorities, and we have plans to expand. This is like, you know, the fact sheet of the Alliance. You can see that we represent 166,000 students with 15,000 staff, and as you will see later on, and I will describe you, we are creating research hubs. So I'm responsible for the Photonics Hub, where people from all over the Alliance and beyond the Alliance, because we would like to increase the impact of Alliance in photonics, we have created a platform. We organize talks, intensive programs, but also we plan research activities in this topic. This is an example. So the ATHENA highlights, I try to summarize here. We are working as a university, which means that we have our governance, we have our executive board meeting, which is the directors of the Alliance, we have the vice rectors of education, we have the vice rectors of research, different decision makers, and for the last 2 years I was operating as a general secretary. So I was the interface between the decision makers and the working teams that are the steering committee, the internationalization committee, the industry interface committee, and also the student board. We are very happy, and this is a priority. If you would like to get involved in an alliance, students, they should participate in the decisions. So you should involve students in any kind of activity. From the curriculum, from the internationalization, they should have a voice. And this is a priority of the European Commission. Not only the pedagogies that we discussed during the last 4 days, but also in the decision making. And I will show you what we are doing. So we have organized our rectors. They operate since the beginning of the vision, because these are not projects. European Commission gives you 5 million euros or 14.4 million for the next 4 years, are not money to run a university, but are money to organize, to shape long vision. It's a long collaboration, how can I say, commitment. So we operate as a university. We have 20 rectors meeting. You know, these are some photos from the face-to-face meeting. This is like last week in Siegen. And we have, you know, this structure. So on top of this structure that everything is operating right now for the last 3 years, we have the student ESN network. We were the first alliance that we signed an agreement with Brussels in the level of this Erasmus student network in an alliance level. And also we have our legal office now, the last 2 years. So the legal office has a lot of work to do, because there is no legal framework from the European Commission how these alliances, they can be registered with one pick. There is no law about this. The alliances, they are working in order to propose to the Commission what kind of actions they should do. So the Commission is now bottom-up process. They would like from the universities to propose solutions. So we try to use existing solutions that they exist in order to big alliances, not in the higher education, because in the higher education, nothing exists. But to use existing tools, make some modifications, pilot these modifications, and then apply. Regarding the education, the activities that they have been undertaken until now, for example, here you can see a joint course that I ran for 3 years together with Porto, University of Cusano from the Alliance, but also Politecnico di Milano outside of Alliance. So this is one approach. I had to lecture in a postgraduate level 12 lectures in this topic, but I collaborate with my colleagues from the Photonics Hub, and I did only 3. The rest of the lectures, they were provided by guest lectures from the Alliance. This helps the students in order to be exposed in a different teaching styles, but also helped me to provide something more complete, because I don't have the expertise to cover all the lectures, or if I would like to give a deeper depth of my course, I have the expertise right now because of the Alliance. Here you can see also the competence cluster, which is the ATHENA European University pedagogical model. So we have grouped, as you will see, our courses in our course catalog. The courses, all of the courses are linked with learning outcomes, but also using ESCO taxonomy to competencies. So the model, what we would like to do, the vision, is like our students, when they enter to the ATHENA Alliance, to select their learning pathway based on the competencies. So they don't pick up courses, but they pick up competencies. And these competencies should reflect the 360 ECTS units at the end of each diploma. So it's not that the university, they structure, you know, this is your curriculum, but the students, they pick up their learning pathway in order to achieve, in order to implement and have the competencies that the diploma, the bachelor degree requests at the end. The other thing that we have, and this works very, very well, is the blended course that we have. We have a blended course in data science. So companies, we are working together with the IMEC, which is a group of startups in Belgium, a very big group. So they provide each year a problem to our students. So the students, we are meeting face-to-face in one of the campuses. The companies, they present the problem. The students then, they create, you know, multinational teams. This is a semester course. They meet online during the semester, and then we meet again in order to present their solutions in front of the companies at the end of the semester. So this is something that we have tried for 3 years. The students, they like it a lot. At the beginning it was challenging, but because they have to perform and provide real solutions. It's not like simulations. You know, the companies, they have a problem. And, you know, it's not only an obligation to present a solution. The companies also appreciate the effort of the students from the consulting point of view. So to see and check that the students, they can back up, you know, what they have done, what kind of difficulties did they face, and how do they justify their results, and what do they offer, and what do they propose as a future steps. This is something also companies are looking for, because the young minds are the future innovators. We have a COIL course in database, so existing courses, they are meeting in some predefined periods in order to have some joint activities. So we have demonstrated this with 7 different classes from 7 different campuses during the last semester. We have organized 12 blended intensive programs. I will explain how to organize a blended intensive program. It's a new tool the last 2 years from the European Commission, provides a great flexibility to the universities. First of all, because you can increase the intercultural, as we mentioned yesterday, intelligence within the classrooms, but also provides a flexibility to the university to follow the technology advancements, because you can introduce very fast, in an accredited way, new technologies through your program, that the university, the standard curricula, probably will take 2 years or 3 years in order, you know, to do it. We have organized 4 intensive programs, one of them together with EPFL. We have received, before 3 months, an Erasmus Mundus grant, 6.5 million euros, in order to attract any student all over the world. So the ATHENA becomes a hub. We have the funding in order people from students from India, China, to have a grant every month for 6 years in order to come and study nanotechnologies. The program is related to nanotechnology and sensors and IoT. Vilnius Tech is a part of this program, as you know, from the partners of ATHENA that they are here. We have received 6 new Erasmus KA2 projects. Why I'm saying this? Because we have got more money from collaboration than the program itself. What I would like to show with this is like building alliances, independent of the European University Alliances, gives a strategy. Gives, you know, to the people that they are going to evaluate a good proposal, that this have an impact to many people. And these people, they are working with a strategy to reach something. So alliances is not only forbidden, you know, if you are lucky to be among the 50 or the 60 next year, but alliances can be built even, you know, here, you know, through this event. And this gives the provision and the strategy that you would like to go somewhere through collaboration. We have the ATHENA course catalog. I will share, you know, my transparency. You can go, and we have generated a full course catalog with more than 1,500 courses in English, which means that it's up to the flexibility of each one of the international relations offices to use these courses, contact, the professors, and they can deliver them face-to-face or online. Or you can organize through these courses invited lectures to your university through your modules. And of course, we have our Moodle platform. Now, the next step is to organize the Athena Open Courseware. So what I would like to do, like in similar case with MIT Open Courseware, to invite speakers, lecturers from the Athena to deliver this asynchronously, so to create a platform and service like this. And also, this is another challenge thing that I would like to do in order to extend the blended intensive programs to create minor programs. So, specific specialization for undergraduate students for 2 semesters in an optional level. So Photonics Hub has done a BIP. Now we would like to do a minor program in photonics, so someone to introduce to this technology within 2 semesters in an optional manner during his or her undergraduate studies. For example, as a fruitful result of this meeting, the local department here can organize something in diets and nutrition technologies, artificial intelligence in nutrition, for example. This could be something very attractive and helps you to follow the technology in a fast manner. We have done this course as well with Perovskite Technologies. It's going to run continuously as a joint program, as a joint course with EPFL. So the Alliance works with EPFL in Geneva. This is the Erasmus Mundus I talk about, and this is an example how we can start with a course, a single course in soft skills, then we move to BIP, and now we would like this to be integrated in minor, and from minor to be integrated, as a satellite part of another Erasmus Mundus project. So I would like a little bit to specify about BIP and help you. Probably I'm doing mistakes, but this is my experience organizing, BIPs, that it's something very, very attractive. BIP, is an acronym of blended intensive programs, are short mobilities. You can see that these mobilities, they can start, from 2 weeks up to 10 weeks. Usually, the usual scenario is 2 weeks, 1 week online sessions and 1 week face-to-face activities. This is like by 90% the scenario that the people, they follow. The main motivation of EU in order to introduce BIP is inclusivity. They would like to introduce mobility and internationalization for short period in order the people to overcome their fears, to overcome the hesitation that they have in order to go outside of their comfort zone. For students and teachers as well, because as someone mentioned, the biggest obstacle in the universities are not the students. The students are young people, they are probably more brave than us. I think that it's us that we would like to follow an established way, how we have learned, and our ego. So these kind of activities are already accredited. So if your activity is a new course, you should follow the accreditation very fast as an optional course. So whatever you are doing is going to the diploma supplement. But my tip on this is like engage the BIP, integrate the BIP into the existing courses. So 3 ECTS will be part of an existing course. This is like the motivation for the students to participate, and of course you should follow the process and the bureaucracy with the university to sign learning agreement. Why learning agreement? This is a contract for the student that follows the process to the 3 ECTS to be accredited, and also bilateral agreement, because if we don't have a big bilateral agreement, we need to sign a bilateral agreement for this short mobility. This is an agreement between the institutions. The advantages for BIPs, of course, is quite straightforward. You develop the soft skills, you develop digital literacy, because it includes for both sides, professors and students, the digital interface, supports the hybrid mobilities. Right now, Brussels, since they have a big target, they would like 50% of students and staff in the next 5 years to have mobilized within Europe. 50% is a very big number if you take into account that the average mobilities right now in the universities, after so many years of Erasmus, is only 3%. So from the 3%, with all this investment, they would like to go the 50%. So they have started to recognize, and thanks to COVID, because COVID opened our eyes. Unfortunately, a lot of people died, but they would like to include the virtual mobilities as well, because because provides inclusivity. You can engage people that they are working at the same time, and they will never have the experience of internationalization. People that they don't have even the money to do to implement a mobility. So they have announced that virtual mobility somehow are going to take into account to the mobility figures of the university, which means ranking as well, impact to the ranking as well. You can include the companies, as I told you, and in the case of the BIPs, we have included Boston Consulting in order to provide us the workshops during the face-to-face in the soft skills BIP that we have integrated here, or IMEC for the technology BIP that I was speaking before. How to set up a BIP? You need 3 partners. The minimum, you need 3 partners. Yourself as an organizer and 2 other universities. You need to have 3. My suggestion is like to have 5 universities. Because as you will see, in order to exploit the funding that only the European partners, these BIPs regarding funding does not correspond to our partners in Israel, Ukraine, or KA 171 partners. These partners, they can participate, but they don't receive funding from European funds. So I would like to suggest you to have 5 partners, because in order to exploit and leverage the funding that you have received as a university, you need to have minimum 15 incoming students, which means in the face-to-face, which means that your students, they don't count, or 20 students and above, in order to receive the 6,000 euros for organizational purposes, or the 8,000 euros in the case that you have 20 students. So you don't want to have last-minute surprises. You have count, for example, that you have 15 students, and until the last moment, you can use this funding from the university, but suddenly, as happened, to me, someone is calling you, I cannot come, which means that you are going to 14, no money. So if you have the buffer to have 5 partners, you don't go, your target is not 15 students, it's 25. So you have the buffer for any changes. In my opinion, you should not approach and organize a BIP in institutional level. Go and find individuals in these institutions that you trust. You have collaborate in order to be sure that everything will run smoothly. You should design the online part, which is usually the theoretical part, or activities that the students and the staff, they get know each other, and then you have the face-to-face that I strongly suggest you to include workshops. Activities that the students, they will work together, they are going to be active and engaged, and in collaboration with companies or innovators. This, inspires the people and students and staff. The challenges, there are challenges. First of all, the financial support that our students receive in order to go to a BIP is 70 euros per day, and that's it. Which means that if you have a 5 days activities, the people, they will be away 7 days, because 1 day for flight in and then 1 day for the flight out. The students, they are going to receive close, a little bit less, 500 euros. And with the 500 euros, the students, they should pay for their flights, for their accommodation, for their catering during these 5 days. However, the host university receives 8,000 euros for organizational purposes in order to organize BIP. So in the majority of the case, at least in our case, and in the case of Vilnius Tech, that our students are going very frequently through the BIP they are organized, we secure through this organizational money the catering, and in some cases the accommodation of the students in the case that the student halls are available. So we lower the expenses of the students. So this has to do with what did I say before? You should organize BIPs with people that you know in order to make the communication faster and communicate them activities in order to support this participation. The minimum participation is something that you should take into account from the very beginning. As I told you, 15 and 20, depends on the grant that you are going to receive from your institution. 6,000 euros if you have minimum 15. If you have minimum 20, 8,000 euros. If you are above this, if you are above 20, 8,000 euros again. If you are above 15, 6,000 euros until you are going to reach the above the 20. So it's very crucial to have this minimum number of incoming students. Your students, they don't count. Not on the online sessions. I'm talking about these numbers on the face-to-face sessions. All right? So be careful on this. And there is a minimum bureaucracy. But I told you, the bureaucracy is there because as an academic always, bureaucracy, crying. But the bureaucracy is there in order to secure our students. This is the learning agreement in order to be accredited these 3 ECTS. We should be responsible to them. And also bilateral agreement that this thing will happen. The money will be exploited between the universities. So one contract is like universities and students, and the other contract is like university to university. So this is the minimum bureaucracy that we have. The impact of BIP, I will give you the example. In Greek, the Greek Quality Assurance Agency, one of the criteria are mobilities. Incoming mobilities and outgoing mobilities. I mean, imagine that we have 3% average right now for mobilities in Europe, and if the BIPS has not been introduced, you are waiting for semester mobilities, or in case using the Erasmus funds, which means that, each university, should, in Europe or, within us, I'm not talking about English curricula, that the people, they pay fees, using, the Erasmus projects. We should have, from what I have heard, something like 120 up to 200 incoming students per year. But these activities, I will show to you, we have organized, and I have participated in the organization of 3 BIPs. Increase your mobilities within a week to the same amount. All right? So, an impact, a direct impact on number, it has a direct impact to the ranking of the university. I don't know what is happening in Israel, I'm talking about Europe. All right? So, the first, the most successful BIP that we have organized, it was like together with Israeli universities. But we were lucky because all the Israeli universities, they have financed their students to come. They don't have money. And we try to facilitate, this during their stay. So I would like to say on this, it's not only the individuals, everything starts from the individuals and the trust between the individuals, but also is the vision of the university that you are going to collaborate in order to have more internationalization. So take into the account of it. We had, for only one, we organized 52 students, incoming students, 52. I'm not counting the teachers. So one course, 1 week, and I have, as a university, I'm responsible for the International Relations Office, 150 students per year. And within 1 week, 1 BIP, 52 students. We had 3 BIPs, which makes close to 100, because the others, they were lower figures. And as a university, we have secured for our departments 11 BIPs. So, as a Hellenic Mediterranean University, I have secured for each department to organize 1 BIP. Now the people, they are coming and they are asking money, I want, money for dissemination. Oh, now, my answer is the following. Money is here. You are going to work in order to get your money. Okay? This is, life. You cannot ask without doing anything. Because of the BIP, we organized a series of colloquia talks in soft skills. So over there, we name them the ATHENA Career Talks. This happens because of our collaboration with Israeli universities, European universities, and here is your colleague from Holon, because you are looking for this. So we managed to introduce market with our students during the online. Online provides excellent flexibility. Now I'm keeping notes continuously. I'm going to invite some of you to the next phase. And if you would like to join our BIP in soft skills, now we are 15 universities. You are more than welcome. Vilnius Tech is a part, so you don't count. But there are other universities here that we are very happy to include you. With the people in Israel and Albania, as I can see here, we can exploit the KA 171 funds for students and teachers as well. Now, what is the future and what is the continuation? Because what we are doing regarding any activity, we should go as Olympiacos fans, they say, to the end, and Panathinaikos, but this is independent. So, we started with some online courses. This started, as an inspiration of COVID. Then we moved to the blended intensive programs, and we are very happy that because of this story, we have not completed the story yet. We got another grant of €500,000 to organize a virtual exchange. So our course in soft skills, as an exam, this is an exam, of few invited lectures in HMU moved to happen a bit, that more students and more teachers, they have been involved. And now we organize for the next 3 years a whole set of online activities to develop the soft and the digital literacy of our students and staff. And if you have a story and if you have a motivation, you can see how the funding comes. No funding here, only personal effort of my collaborators. Limited fundings that, had an impact to the university, however. And then €500,000. And more are coming because we have this, the Soft Skills Academy, and now we start to organize things together with other people, associations, UNESCO, UNICEF, they can be included. So you are more than welcome, and I will send you the emails, your students, to join this. Classes, students all over, from Israel and Morocco. Also, it had a political impact because it was the first course, the first educational activity after the Abraham Records, agreement, that Arabs and Israelis, not Arabs, people from Morocco, and, Israelis, they are going to collaborate. And this is like the young people. So probably this can inspire others to collaborate as well in political level. Let's see, but probably I'm romantic, I'm outside of this region, but I'm very happy that we are going to trigger such an activity. We are going to speak about internationalization, sustainable development goals. The students, they will propose through the activities what they want in research, innovation, in the university campuses. This is the motivation of these things. We have our ATHENA colloquia talks that we were talking. We have organized more than 80 invited colloquia talks. You can go to our website, 2 Nobel Prizes. Winners, they have participated, 20 invited talks in modern pedagogies, 25 invited talks in teaching mathematics. Why teaching mathematics? We are talking about artificial intelligence, am I right? No, mathematics is the key competence in order to develop this technology. At least to understand, not to become a deep and heavy mathematician. 18 seminar lectures in soft and digital literacy, 4 round tables, and collaboration with Foresight Institute. Who knows what is the Foresight Institute? Foresight Institute is the European Commission tool that studies how technologies will come in the future. So it's a study group of technologists and industrial and people from industry that says to you, in 20 years, the technologies will be this, this, and this in all topics. So if you go, you can click this, Foresight Institute of the European Commission, and you can identify a pool of essays and reports, what is coming. And this is the official tool of the European Commission. So we have done, invited people. Now I'm starting, to call, and Serastiskis, you are going to send me the email. And not only this, as a European alliance, we have created our research book, registered, in the Google Scholar. Now you are going to ask me, I would like to publish in Nature or in Advanced Functional Materials. Why to publish here? But this is a great opportunity, first of all, for the research groups to get to know each other, and also we provide floor to students. Students to publish. Of course, the reviewers are coming from Weizmann, Imperial College. The reviewers, are serious people. But this is an opportunity for our researchers to get to know each other, a part of the colloquia talks, a part of the intensive programs, a part. So we are very happy that we have published 2 of them, and also we have created our research platform. So we have a platform that all the researchers, almost all the researchers, this is impossible, they have registered their specialization and their laboratories. So if I would like to write a proposal and I'm looking someone in optoelectronics, I just click to the search optoelectronics, and a list of colleagues with contact names, with the laboratories, they appear. I want to do this because European Commission is very biased to the alliances in general. They would like to invest their money to alliances because the political impact goes to 9 different countries, to 9 different universities. So it's also a political action. The European alliances is a political action. You should think about this before you apply. It's a long commitment contract and it has political motives. So we have also, let me go back, we have created our research office, grant office. I would like to show to you, but I will do later on, that every day in 24 hours, we announced all the available calls for funding opportunities, Horizon, Cost, Erasmus, every 24 hours. This is one. The second service is we provide all the trainings that European Commission offers, because this shows to you where technology is going or what are the future calls will be available, and also the info days. So all the videos, all the training, all the funding opportunities, we have a platform, ATHENAgrantoffice.eu, that also you can use. I will send you an email. Every 24 hours, all the calls available. All right? The next step that we would like to do is beyond info. We would like to create a group of people with experience in writing proposals in order, first service, to help our scientists to make the network, to identify researchers in order to make the network of universities, and in the third level, to consult them in the writing, not in the scientific part, because it's obviously is beyond our expertise, but other things, other sections like the impact, dissemination, and also the proofreading and a second thought. Okay, let's move. Then we have our group of people that are working with industry, the Industry Interface Committee, that they help to identify and organize activities that will help us to collaborate with industry. So we have organized 2 workshops with industry in order to identify what do they want. It was very hard because I think that the people from industry, they are hearing us like extraterrestrials. They have other priorities. But it's nice to establish this network and this communication channel. Here is like a part of our activities, this forum, but also we have a network of the Fab Labs. Fab Labs are activities that is an interface of the university with the society regarding additive, manufacturing techniques, 3D printing, robotics, and stuff like this. So these are some pictures of this. So we have other activities regarding the internationalization of Athena, the Athena Aero Cafe, that every week the people from Aero, they discuss joint programs. We try to establish the Athena student card, but this is impossible because this student card never exists. Europe would like to introduce, but this does not work. And we have our sports events like the Athenathon, that we organize sports events for our students. And we have organized 3 international weeks, mainly in Crete. This is a picture from our last one, from Hania. But also we are very proud of this one, that you are part of this, you are part of Athena, and I think that we can do much more things in this thing. The main thing is like, what did I say to you that Athena established, and this was very highlighted by the European Commission about the Athena student network. So all these networks, they become one, and they operate in the level of alliance. And in next week, or in 2 weeks' time, we organize these political roundtables. So I will send you the emails in order to participate and ask your questions. If you would like to build your collaboration with Africa, we have African partners, we have European partners with a great experience working with Africa in order to discuss what were the challenges and the opportunities. Why Africa? Africa is a continent with the highest potential in order to develop in education and the research. So it's a great opportunity to listen to their needs, in order to address their needs, through the collaboration. We would like to, the next day, we provide the floor to our students to speak to us, as I spoke yesterday with 3 of your students, and they have a very nice insight, and, they give me, very useful information. What do they need in order to increase the internationalization within their campus? What they are looking for? We have the academics as well, and then we have the impact of the European universities. Here we're going to make a discussion with other alliances. What are the challenges, the opportunities of this experiment? Because this is an experiment. And II in higher education, we would like also, some of you are going to participate in this roundtable as a panelist. What is the impact and of artificial intelligence? What is the next period vision? I will say the vision, and I'm not going. I think that, and this is my suggestion to the alliance. We are a ATHENA means Advanced Technology Higher Education Network Alliance. So it's a technological universities that they are engaged. But I think that we should advance this and interlink all our activities, all our departments through our activities. And I think that the only thing that links the past and the future are deep technologies. And the deep technologies, this is a book that has been inspired me a lot, but there are a lot of them, the innovators, in order to see how the innovators, how many failures did they have before they achieved. I think that the deep techs can address everything. An example of the impact of the deep techs and how fast do they provide solution? COVID-19. Within 3 months, 6 months, the scientists from not only, from pharmaceuticals like medical stuff, but also technologies, they worked in order to have, this suggestion. All right? Sustainable development goals and etc. are things that we can address. So I think that the future, and we would like to integrate this under the deep techs, and these are like a list of deep techs, because some people, as myself, I was wondering what are the deep techs, but are already existed, technologies, but they have an impact in everything. Okay? And I can see, the artificial intelligence or deep learning or however you call it is there among others. So I think that the rest of the things is like has been said. These are, the groups within ATHENA that they work in deep tech. So we have the why. So we would like all these groups to collaborate, continue our work in order to advance and don't only talk, provide money and foster the research. These are the research priorities of ATHENA. So you can see that these priorities are very much linked to what we would like to do. This is our activities in deep tech right now. I would like to tell you something. And this is like, I think that I should, I have until, what time did I start? Okay, I'm going to accelerate. So, that the need of deep tech is not our invention. EIT, European Institute of Technology, which is the flagship of the European Commission, is like the European MIT, let's say. They have a need for the next 5 years for 5 million people to work in deep tech. So we are not going to work in order to advance the technology, but we would like as an alliance to provide the education, the training for students to work for these needs, to fill this gap. So there is a European priority about this, and we would like to be the first European alliance that we would like to address. So let's move. So I think that, I don't have anything else to say. I would like to say to you that among the priorities in the future steps, citizen science is very important. We had a discussion here with a colleague from Vilnius Tech about this, and I would like to say to you that through European Alliance, and these are what we would like to do, we would like to start, at least in the case of HMU, something that is organized or tries to organize to become the best. Of course, this is a dream. We cannot become the best. But every day, if you are working to become better, I think that you are reaching closer to your target. And I would like to thank you, and this was a summary of what we did. Are there any questions? I cannot ask myself. You need the microphone. No, I'm finishing. What time I should finish? 10:15. Now it's 10:15. It's 20 past. She's fast. Yeah. It's better to use the microphone for the...
I would like to ask about BIP. You said the duration could be from 2 to 10 weeks, and it gives 3 ECTS, even if it is 2 weeks or 10 weeks.
It could be more. The ECTS are defined by the workload. So you can spread the activities in time in order to provide the same workload.
Okay, so it is always 3
No,
ECTS?
it's up the flexibility for you to go to 8 ECTS. Or it's the minimum is at 3 ECTS.
Ah, okay, it is the minimum. So the workload is according to the ECTS, so from 3 to 8. Okay, thank you.
So I think that we should call, the next speaker now, because I can see an anxiety. I don't know why. So let me invite Nava. Now I have to pronounce her surname well, so I'm going to avoid, because I forgot how I'm going to... Saket. She's going to continue, I think, her, how can I say, inspiring talks about artificial intelligence. Her talk is going to, is entitled The Grid of Multidisciplinary, Interdisciplinary, and Transdisciplinary Education. And at this point, I would like to say one of the targets of ATHENA is to copy her work. I have to say this. So the floor is yours. She's a professor in Holland Institute of Technology. You have met her, yesterday.
It's an opportunity to thank you, Kostas, because you talked about ATHENA, and the wonderful activities that I am very lucky to be part of, because you are the glue. You are with your passion, yes, you become a glue between us. And you inspire us, and really, I know you for, I'm just saying that in the past few years that I know you, you really, really do your best with your passion to all the time invent yourself and invent the people around you. And this is very important because we follow the passion. We always follow the passion. And this talk today is about passion as well. And I hope to also inspire you, or at least if yesterday if yesterday I left you with questions, I hope to give you some answers today. It's nothing to do with artificial intelligence, and it's everything to do with artificial intelligence in different manners. So let's start. I told you a little bit about myself. My PhD is in computational linguistics from New York University, and I am the head of the multidisciplinary school, which I will talk about today. I've worked in many research R&D institutions in the United States and in Israel after I came back. And I also was 20 years in industry before I came 10 years ago to academia by chance. It was not my intention. It was, like everything in life, karma. And I've been working many years and still today with startups and companies that need my help on artificial intelligence, and my favorite thing is avatars and bots. So even before it was really cool, that the thing that I really believed that, and we talked about yesterday. I want to go back to the 2 books I was involved in. I want to talk about the right one, The Arts of the Grid, because we are going to talk about a grid. What is a grid? Many things to many people, but to us is actually a combination of fields, a combination of traits, a combination of know-how, knowledge, skills. Well, what is unique, and this is a book that we published after a conference. We wanted to do a conference about a grid. So we send a call for papers for all over the world to researchers to tell us what is the grid for them, in the sense that it's more than one profession. 1 and 2 give 3. Anna told me yesterday that she's doing so many things. I cannot repeat all of them, but she's a true multidisciplinary person, and she fits herself whenever she goes to what is needed. We were looking for 1 and 1 is 3, meaning that I'm doing one thing, but I'm doing another thing, and then I created a third. This is what we did. And in this book, the conference was supposed to take place, and Corona happened. And I had a budget and everything, and I had the program, and Corona happened, and we couldn't meet. So we decided to do that online with 4 studios. And it was amazing with a few hundreds of people, and it was really amazing. And then we took the lectures. We asked the lecturers to write a book, and it's available, by the way. It's amazing because it's also what we did in parallel. We asked artists what are the grid for them, and in parallel we had a virtual exhibition, and we have the artwork in the book as well. So this is, and I have to say, my daughter is the producer of the cover. That was the grid for her, truly. She's a designer. Anyway, I want to talk, now I will go back and we'll start from the beginning. So what is the key academic education, the key skills, what is really needed? So we took a survey among industrial companies. We asked them, what do you look for in a new employer? In the area, we are HIT is a technological institute. We produce and our graduates are people with technology inclination. Even if they do design, it's industrial design, and they're really around technological orientation. So we asked the companies, what is it that you expect our graduate to be? These are the features that they talked about. They didn't say, oh, they have to be excellent developers. They have to know artificial intelligence. No, what they wanted is agility, self-learning, soft skills, adaptivity, agility and adaptivity. This is what they talk about. I don't need you to know Python. Python I can teach you, but if you don't know how to be agile, and adapt when there is Corona now, and we need to move to a different way of working and developing, this is what I want. Python, anyone can study, anyone can study Python. And leadership and teamwork, that was also very important. And how you want to contribute. You talked about contribution. You say all the time, we need to contribute, to initiate. I don't know if we are lucky or not lucky, but not everyone wants to initiate and to contribute. The ones they do are the ones that I want to employ, are the ones that I want on my staff, in my student, in my startup, in my company. So this is it. Today we are going to talk about the power of the grid, the multidisciplinary grid, the challenge that we have in education of multidisciplinary traits, and the variation on the team. The first thing I want to do for my students and for you to do it today is to move you from your comfort zone. I don't want you to be in your comfort zone. Why? Because when we are not in our comfort zone, we start, maybe get a little nervous, but we also start to adapt and start to think out of the box. And this is what we try to do with our students. And yesterday we talked about artificial intelligence, which takes us out of our comfort zone, because for 20 years we teach like this, and now we have to move, and now we have to change, and it's scary, and it's it's a change, it's a game changer, and this is all the time we find we need to adjust, we need to be agile enough to work out of our comfort zone. So, the School of Multidisciplinary, which is the only one in Israel and very few if there are in the world, started as an idea. I came to the president of the university and I asked him, I said, can we do something to connect between faculties? The engineering students never talk to the design students, never talk to the computer science and so forth. And we started with an idea of a cluster of courses we offered to the students. What does it mean? It means that students sit and study together, do projects on on areas and topics that are relevant to everyone. I'll show you the example of the courses. And we started with a few and then we saw that the students really like it and they want more. So we became a department, and last year, at September 21, we became a faculty, a real faculty. And to make it all in 2 minutes, I will show you this movie.
Our world is fast, sometimes too fast. Vision the world as a complex grid. The power of the grid is the fusion of techniques, technologies and disciplines, thriving to new horizons. In today's industry, students must have a bundle of skills. That is why we have established MDS, the School of Multidisciplinary Studies, where students from different faculties work together on advanced projects, ideas and concepts. Engineers, designers, scientists collaborating in teams to create projects of the future, developing constructive thinking with emphasis on problem solving and industry orientation. We teach 4 academic clusters in MDS: Humanities and Social Sciences, Integrated Technologies, Community-Engaged Courses, Entrepreneurship and Innovation. And let's not forget our EFL English as a Foreign Language unit and EMI courses. Check out MDS in numbers. Over 60 unique courses in the curriculum in Hebrew and English, 50% of project-based learning in 100% multidisciplinary teams. Over 4,500 students attending each year. With 45 lecturers from various disciplines, the school has developed an updated and unique methodology, leveraging team skills, cooperating, teaching, and researching with one another. Courses like wearable computing, ethics and bioethics, biomimicry science and scientific thinking are just a small example of our arsenal of courses. Imagine a world where things work seamlessly together. One is completing the other, fusing into something new, powerful, bigger than the sum of its parts. A multidisciplinary academics, enabling us to thrive for new educational frontiers. Come visit us at the School of Multidisciplinary Studies at HIT.
So the one thing that really was a game changer for us is the management of the university decided that every one of the students taking a bachelor degree, Bachelor of Science or the undergraduate degree must go through the school, must take certain amount of credit. So it was a positioning, it was a statement. We believe that every one of the students must encounter these multidisciplinary skills in order to be prepared for the industry. And you know, that was the decision that enabled us to thrive and to really develop these projects and courses, which are really varied. And we have around 5,000 students a year in the department with 45 lecturers. It's quite a lot. I want to talk about what is the difference between multidisciplinary, interdisciplinary, and trans. I'm inventing this, okay? But the definition to me is when you do multidisciplinary, you really have a choice, a diversity, and you give new knowledge that the student didn't get in this faculty. When you do interdisciplinary, you give also skills and tools to combine this knowledge. Not only I'm giving you this knowledge, but I want you to use this knowledge now with the new tools, so it becomes something bigger. And the transdisciplinary is really when we actually start a dialogue, start to practice it, start to creatively use it to do the third thing that we talked about, 1 and 1 is 3. The paradigm that we are doing is actually, we are taking these two, you know, you get theory and practice. You get the expertise that you have and the soft skill that cover it, that embrace it, okay? You have tools that are general, but you also, you have tools that are general, but you also have personalized learning. When you do projects, and you do multidisciplinary groups, 4 people in a group, 1 from design, 1 from engineering, 1 from computer science, 1 from industrial engineering, you enable each of them to contribute on a personalized level what they are strong in, okay? What they're strong in. So I'm going to show you the 6 steps that we have for, if you want to follow this, here I'm giving you the recipe. First, and there are going to be some movies of teachers, of lecturers that are in the program talking about their experience. And in these movies, we will have to have the volume up. Thank you. Okay, so step 1. A meeting point for students and lecturer. It sounds simple, but it's not simple, because when you come from different departments, different faculties, you bring your own agenda, your own habits, your own clothing even. Okay, there's a difference of how the design students dress and how the engineering, it's just a fact. I did not, I noticed that. So they all come into one room and all of a sudden it's a meeting point. And you as a lecturer have a responsibility to create a safe haven for discussion. That nobody will say, this is nonsense, okay? No, you are responsible to create a safe haven. How we do it? We do it by self-modeling. How? We have created a model where we don't only bring students from different faculties, but we teach in tandem. We teach with two teachers. One from a different, they are all in the school, but different professions. Okay, so for example, so you will see in the movie. Okay, let's start.
We teach biomimicry as a model for innovation.
Wearable computing, industry challenges. Here at the School of Multidisciplinary Studies, we teach a course named Technology, Communication and the Medical Encounter, in which students from various disciplines design and create various devices and ideas that promote and enhance the empathy between doctors and their patients.
Biomimicry takes design from live organisms and live ecosystems and applies it to human challenges, to design for all and everything, from computer, from design, from management.
She's a biologist, he's a mathematician.
The course teaches the essential of wearable computing with important aspects of the market and the industry. We try to stay updated on the current issues that are relevant.
Which are changing very, very fast every class we teach.
So I teach wearable computing with Eli. Eli is an industrial designer. I come from technology and I'm, you know my background. And we teach together wearable computing. Wearable computing is a course that is applicable to design, to engineering, to computer science, to industrial engineering, to nutrition, to whatever area you think of, to sport, to everything. So, but he's a designer. Sometimes we stand in class and not sometimes, all the time, we stand in class together and the students see their interaction between us and the different views that we have, and we express them politely, but we do express them, and we lead by example. We lead by example. So step 2, after we creating a meeting point, is to develop a multidisciplinary language. How to say things to one another when we come from such a different dialogue. Then we come from from a professional, different professional views. And sometimes we think, by the way, that the thing that we are studying is the best on the world. We know everything. So it's and when we stand two teachers, okay, we have advantages, but it's also a challenge. So let's hear, can you hear when they speak, by the way? Is it not so, no? I'm working on redoing all the movies. In 2 weeks, I'm redoing all the movies, but that was a little bit underground movies, so I apologize for that. When you don't have budget, that's what you do. Then you get the budget, you redo it.
Different insights and different approaches to a single topic make the students see the whole and the complete image or the complete perception of this topic or this field. A comprehensive and holistic approach to any given subject matter.
I think that the first advantage
of teaching
for us,
together.
Since in this case, when I'm going to a conference or to a vacation, there's always someone that teaches instead of me.
You're not going to a vacation. Not happening. No, I think there are many advantages. The first, I would say, it's an advantage that allows us to work with the students differently. We can use much more student-centered approach. So we can do projects, we can guide them to work in teams, we can make it much more hands-on, because it takes a lot of resources. And also, I think the students that themselves are multidisciplinary get to see different takes on the same subject.
And sometimes they prefer working with me or with you. And
yes.
This is, yeah.
So definitely there is an advantage to teaching together. If you learn, and it took me and my partner there, we are teaching for 7 years. This is going to be our 8th year together. Now the student thinks we are married, but before, it took time to exercise for us. It was a lesson for us how to teach together, because we teach together. We don't do 2 hours. We actually all the time there for each other. So we separate. Ken, you look surprised. We actually sit in the class and we divide the topics, but we interfere each other with comments and questions, and we see what's going on in the class. So he's speaking and I'm responsible to see what's going on, who doesn't understand, how can we elaborate on that. It's really looking at what's going on in the class. Then when we do the project together, wearable computing, they have to do a project. So we have the time to sit with the groups, to give them the personal attention, okay? It's a commitment. It's a commitment, and you don't do that if you can't handle extra work. So you need to, Step 3. So after a meeting point and a dialogue, step 3, new, combined, and creative knowledge. Look, we are in an era that we have to be valuable for the students. If we don't bring value, they don't come. Okay, so they don't participate, and it's not fun when they don't participate. So what kind of knowledge we bring? We saw the course biomimicry. We give courses like decision making, but it's not on the soft skill. It's from the psychological and anthropological point of view of decision making. It's not on the soft skill of how to make quick decisions. Well-being in the digital world is a new course that we put because it is a concern how you can be it can be given in your department as well. How well-being in the digital world creates things are changing. How to evaluate a startup. How to evaluate it's actually, Noga, she gives this course. When she gives this course, she talks about failure. The course is about failure. How to fail. It's nice. It's important and necessary to fail. Political campaigning, making sense of complexity. Saifan, the teacher, she's talking about making sense of complexity, not in the mathematical way. Every problem that is complex, how can we simplify? These are tools that they need for life. Not only for the next startup or the next industry. These are tools. When you bring this knowledge, you talk about bioethics, you talked about freedom fighters. We also have an excellent course about freedom fighters. It's not only history, it's about the essence of things, okay? And the fan, the color fan that we bring. How do you call this? Fan. Okay, so this is the color fan that we bring. Okay. So the question now that they are answering is, how do students react to the new approach? Because some of the students are shocked, like you. Okay, they say, what's going on here?
I think it's more interesting for them to see and hear 2 lectures and various attitudes or approach to certain topics.
It's new in the beginning. It can be confusing. It's a multidisciplinary approach, so they are not used to it. But I think that it crosses the threshold and it becomes very enthusiastic kind of response.
I agree.
So the students, first of all, I think they are very surprised to see 2 lecturers standing in front of them. And maybe they are not used in the beginning to the discussion between Nava and myself and between them, but slowly, gradually they understand that they are part of the process. We have an open discussion.
And I think they even like when we have a debate and when we disagree on things, and then they can see the different aspects and what each of us is thinking and how it doesn't have to be always the same. I think this is very useful for them for the future. So the rule is after they start to understand after the third class, after the third lesson, after the third week. They say, okay, because the first 3 classes, they are a little bit shocked, and they don't know if they like it, they don't like it, and what does it mean? Does it mean more work? What does it mean, okay? So it takes 3 classes for them to relax and to understand that it's actually a good thing that is happening here, and then the feedback that we get is very important. So this was step 3, and step 4, which is very important, is teamwork. I think you can sense even with the movies, even if you don't hear anything, just the body language, you can see that the teams, the teachers, they like each other, they work together, and they develop a kind of teamwork, okay? And the same, we want to inspire the students with the teamwork. Meaning, you know how you divide. First of all, we tell them, listen, we scare them, of course. We tell them, you divide yourself into a multidisciplinary team. We really recommend it. And if they don't, we pressure them even more. And then we let them, the ones that did not divide, the ones that wanted to go with their friends, they are the ones that are getting a lot of problems afterwards when they have the project, because the project requires all the skills. So it's a lesson to them in a sense. But we really ask them to divide into multidisciplinary groups. And it's a project-based and a problem-based. Sometimes we bring people from industry. For example, the course that Yoel and Gili are giving, it's called the medical, how to improve the medical encounter. Meaning that we bring both technological and non-technological ways to improve the medical encounter between a patient and a doctor. And how to do it. Yoel is an anthropologist, his PhD is in creativity, and he's also a medical clown, and also an improvisist actor. So he puts all of this into the course. They are doing improvisation, they are doing a lot of creative thinking, they are deploying everything into such a course, and they come up with solutions. They came up with solutions that won many prizes this year. This course is one of the best courses we have, because it talks about a real problem and something that every student can encounter in his everyday with his family, but also has a lot of technological, social, and humanitarian effects. And we also bring people from industry to present industry challenges. So we bring people from startups, some from traditional industry to talk about their challenges. So this is how we create the teamwork, and again, we always lead by example. If the students see us behaving in a certain way, they will imitate us. This is pure, simple psychology. So, yeah. So how does teaching actually work? How does it work in the class? We split the time between us, but in fact, when we go to the classroom, each of us give his topic, but both of us are participating in each other's lectures and contributing from our knowledge.
We try to divide the time we have with the class in different disciplines of the industry, technical, wearables, and we have a discussion between us and between the classroom.
We try to make it very, very interactive and show them different aspects of each of the topics that we introduce.
We share the work, which means we usually try not to do the same. So there are some parts of the course that I present, some that Elad present, and also we divide
There is a theoretical part and a hands-on part, and usually we just divide it between us, and we plan everything in advance.
working together is like a dance or just playing together a concert. But there's no chance that this concert will succeed if the other partner is not playing together with you and is synchronized with you.
Yes, I think that we support each other in the sense that we are both in the classroom and we complement each other's ideas. Sometimes even on the spot. It is, as Gili said, like a work of art. It is part plan and part improvisation based on the interaction between the two of us and the students, of course.
It's like a dance, it's like an art. It is a dance and an art. When you dance, you need to look at what your partner is doing and you need to adjust. It's all about adaptation. It's the skills of adaptation. Step 5, this is for you, Kostas, international activities. So
I'm not included in dance.
So I realized that this kind of department, this kind of school will not have, if we don't start to talk not only with ourselves but with others outside the institution, it will not develop. And we started international activities. The first thing we did is we looked for partners in Erasmus and we signed Erasmus. And again, I invite you all to participate, partner with us. We actually need to be invited because Israel is not part of the union, but we are worthy partners. We also have a set of English courses which we give online. For example, this semester, how to evaluate a startup is given in English. We have a lot of speakers a lot of lecturers that studies abroad and their English is very good. So we have a set of lectures that each semester around 4 or 5 courses that are given online, and we can share with you and we invite you, and if you are willing to give credit to your students, that's fine with us. What is the added value of that is that really they not only get the material, but they interact with students different than them and work in groups, even if it's online, work with groups, and it's another step to understanding of others, to know people, to see mentality, even if they don't travel. They just, in an intimate class, 30 people, something 40 people maximum. Okay, so I offer this to you as well. Of course, we cooperate with Grant Research and Erasmus, and as you saw, we published the book. It was an international effort from all the people that participated, and I think it was one of our great achievements. This is Hillel. Hillel is responsible for the international activities in the school. He will say just one word. Why to offer English multidisciplinary courses?
Multidisciplinary courses are a great opportunity for international students as well as for Israeli students. It allows both sides to interact with each other, learn about the life experience of other people, and it's also great for all sides involved to learn from each other and bring different things to the table. So when they work together on a project or study together, these international courses, which are of course taught in English, are a great learning experience.
This year we're going to have 3 or 4 coils that, like Kostas mentioned, we have managed to sponsor 4 courses like that, and it's not easy, but you manage to do that when you show the added value, when you show also that, again, we are being asked to join to these courses. We cannot initiate, so being asked, which is a great privilege for us. So it's nice, we have good partners in Belgium and in Greece and in Portugal and in other places, and it's really a pride and joy to be part of that. So the 6th step, and the last one, is facing the challenge. So yes, it's wonderful what I told you, happy, happy. No, there are a lot of challenges, because when you bring 45 people together that are different, that come also, not only, they don't come, they belong to the school, okay, but nevertheless, one is an anthropologist, one is a biologist, one is a technology, AI, and one is the ethican. It's really different. So you have to bring and give them one mission, one vision, okay? And to show them that we are advancing. And the truth is that doing the international activities, getting the feedback from the students that they like it, having good reviews from the High Council of Education, these are also things that help me as a manager to show my team that we are going in the right direction. It's not easy to create a one language. It's not easy to lecture in tandem. And the one thing I want to talk about is the quality assessment. So quality assessment, you have these questionnaires which you distribute to the students, but nowhere there is a quality assessment for multidisciplinary studies. And also not only for the students, we wanted to do quality assessment for the teachers to get feedback. And then, of course, there is a question, how do you do this quality assessment? Do I ask Anna to go into the class and to measure them? So we came up with, and we published in Portugal, we presented the paper in June. We came up with a 3-layer assessment, quality assessment program, a multi-level assessment it's called, a methodology which includes also peer review methodology, student review, and acquisitions of skills. I can send you the paper. It's really interesting. Yeah, I will send you. We are measuring let me repeat. This is important. We managed to convince the 45 lecturers that it's okay that somebody will listen to their classes and will give them personal, this is peer review, give them personal review, not to me, not to report to me, from one another, between them. You understand? So it's not, they are not reporting the assessment, the quality assessment to me. I am watching your class and I'm giving you personal feedback. I'm telling you, listen, it was wonderful, but you know what? I would give this assignment, this will trigger, and you say, oh, wow, this is wonderful, I didn't think about it. The peer review is something very powerful to build trust and confidence between the teachers themselves. So this is a methodology also that we had, there was nothing. We needed to develop it for ourselves. So facing the challenges, step 6 is, again, not easy. No, I'm skipping this. So what did we have? No, I want to, yes, I want to go here. Yes. Okay, we summarize. So we talked about the different clusters that we teach, the social and sciences and humanities, the entrepreneurship. We didn't talk about social intervention, but you saw in the movie, we actually go into community, into schools, and we do projects there. We talked about the teaching quality program, industry orientation, the English courses, the research, and the international project. This is all has been done, and the 5 years that the school exists officially. And at the end, this is my message to you. It is why it grows better in the forest. It's never a competition, it's always a collaboration. And this is my message to you, and I offer our collaboration with you. And thank you, Efcharistopouli.
All right, before the questions, since we have set up here, please come here, sit down there. I will take a photo. Right? 1, 2. Now, wait. No, I can take another one. This is the last order. back to your place now. All right. First of all, I would like also, before we start the questions, I would like to introduce you the ATHENA coordinator, Nuno Escudeiro. Nuno... And also Nuno is a very big fan. That's why I say to you when I finish, ATHENA is following your progress very close. Bye.
Well, thank you, Kostas. I was not really expecting. Thank you very much for joining the event. Thank you very much for your presentation. I'm really sorry to be late because I put my alarm clock on the right time, but on the wrong day on the weekend. So, okay, anyway, thank you very much for being here. I have lots of questions for you, but I give the floor to the rest.
Thank you, Nuno. And question time starts now. I think that it was someone else from this side. I will give you the floor. Who was? Yes, Angel. Sorry, I have to follow the order.
So, thank you, Kostas. Thank you for the excellent presentation. You said before that it's difficult for the students to adapt their needs to on the third class, they understand what's going on and blah, blah, blah. But let me ask you, about the professors, on the other hand, because you said before that it's difficult to leave our comfort zone. How easy is for these professors to leave their comfort zone and to do something very new, something that they haven't learned before? And
well, if I had €1 for every time I was asked this question, wow. Wow, it's amazing. Yeah, sure. It's amazing that this is the first question. You know, you remember what we said yesterday about artificial intelligence? It's not difficult for the student. It's difficult for the teacher. Exactly. I'm trying to be polite. I have no meaning. Okay. Two parts to the answer. One, I am sorry to tell you, we don't have a chance. We need to change. We don't have an option. It's live or die, okay? If you want to be this boring professor, this and doing, the students will not come. You will not enjoy your work. The students will not enjoy. We don't have a choice. I don't know how to say it more clearly. We do not have a choice. About the other thing, I have 45 lectures. Not everybody is teaching in tandem. It's the ones that are able to do that, and also they don't get extra payment for that. So they have to be motivated. You know what motivates them? Then after they do the project, the students win an award, and then they get, that's something that motivates them. So yes, if you have a part of your staff who is not really so they will do the regular way, and there is room for everyone. But the ones that are the first ones, the ones that want to go ahead, the ones that are more ambitious, the ones that are not afraid, you take them and you start with them and you lead by example. That's why I also took the first courses. I was the first course to do. I was lucky that my partner was really participating with me, and here we are teaching. This is the 8th year. Okay, so yes, you are right. It's not for everyone. Choose the good ones that fits the task.
Because
I'm sorry if I didn't give you any...
No, it's okay.
No.
Hello. I would like to ask you about difficulty I thought about the different discourses. Do you establish the common semantic field between two disciplines before teaching, or I'm not thinking only about specialistic vocabulary, but semantic fields?
You're right, because don't forget we teach, for example, when I teach wearable computing, so we set the vocabulary and the lexicon for wearable computing, which most of the students don't know. So we start with that. Then along the theoretical thing, we also have practice. The practice includes professional, but also soft skills. So I'm not assuming that, since usually we have presentation, that we ask them to do presentation or a demo. For example, the output of the project should be something that is demonstrating their concept. Okay, I want to develop a wearable computing device to monitor nutrition. We had something like that, by the way. And we had a smart table also, like where you can choose what you want to do in a restaurant, and you can get all the nutrition about that. You can demonstrate it according to your skills. So you don't have to, if you are coming from computer science and you want to actually develop an application, it's fine. But if you come from design and you want, I don't have time to show you, but they can do a simulation movie that shows the project, that shows so we are giving the freedom of what language you want to speak, but the general concept has to be the same.
Yeah, thank you. Well, one important question from my point of view is about accreditation. Do you had to do any changes in your courses to have this accredited?
So this is the thing. We have courses, well, we don't count the same, but we have it's 2 points is like more or less like 6 ECTS. So we have courses for 2 and for 4. The courses for 4 are the ones that usually have 2 lectures. They last 4 hours, the course, and usually a project. So it's more of an effort for the students. But we discovered that sometimes the students like projects more than tests. They prefer to take that because some of them get a lot of pressure, and the way the course is built, that you start from the project almost from the beginning, and then it's easier for them, although it's more work. But again, it's psychological. It's not the pressure of a test, but it's the constant work on a project, which for me, I must say, as an educator, much more, I never, in my courses, in artificial intelligence and all that, I never give tests, never. I don't believe in tests, sorry. I don't believe in tests.
Yeah, about I was talking about accreditation before your governmental institutions. Recognition of the course as such. Do you have to change anything in the accreditation, in your accreditation agency, for instance?
No,
because you are applying this in project courses that are already there. Yeah.
We are our own faculty. I am a dean in the faculty, so I decide.
Okay. But these courses are curricular courses, not extracurricular courses.
Yes. It's you can see the site.
All the SIT students, they should pass through.
If you do engineering,
to get trained for the industry.
If you do engineering and you have to do 140 points, for example, 10 points needs to be in our department. So it is given in your I don't know, curriculum, the part that you have to do.
Yeah. Do you find any difference between the motivation of the students that are attending online and those that are attending in face?
It's an excellent question. Okay. It's an excellent question, and I think it's not only to do with the multidisciplinary, but in general. Yes. Because I teach also I teach in computer science, I teach in data science because of my profession. Corona changed everything, really. And but also the students don't want to come to class. They prefer to sit in their bedroom with their underwear, and sometimes you can see the underwear. I mean, it's ridiculous if they open the black screens. Don't laugh. I know you know what I'm talking about. So if they even open their screens, okay? So it is a challenge. We made a decision in the faculty that doesn't exist in other faculties. We actually mandate 80% presence for the non-online courses. I mean, we check presence, we check. The ones that are online, it's not 100% online, it's 70%, always 70% online and 30% in class. So if you have 13 weeks, you have 10 online and 3, especially if it's a project or something, it has to be in class. So there's nothing like you never saw the students. You never talk to the students. So this is, first of all, very important, the 7:30. This is how we call it. We call it the night strip. The night strip is courses between 8 and 10 in English. This is why it can be available for your students as well. In English, 70%, of course, if you come from abroad, you don't come to Israel, but it's 70, for the Israeli student, it's 70% online, 30% in class. Yes, it's a struggle. It's a struggle. This is why you have a lot, you need to, we do some activities with the breaking rooms, and we give them presentations, and we ask questions, and we beg for them to open their cameras. And most of all, you need to be interesting. And this is my friend, Angelos. This is my friend, one of the challenges, how we, another thing beyond your comfort zone, how we can make, we are in the business of making ourselves more interesting. And it's not easy. It's not easy.
Thank you. Just one final question from my side. Well, you mentioned that you are partnering with Portuguese. I'm really sorry that we are not your partner, but who is your partner in Portugal?
No, we are working. We are not. We have an agreement with Beja University, and we are looking for more partnership.
Okay, we will apply for sure.
Okay.
Thank you.
Anything else?
Any other question? I have one. Okay. You should switch off your mobile phone.
I have a very general question. Can we have a bilateral agreement with different departments?
In this case, look,
For staff mobility, at least?
It's like for the partners in the KA 171, the agreement is between institutions. So with Israel, we have a specific number of mobilities for the Israelis and for Greeks. So whenever you would like to visit Nava's department, if there are any available positions, because I block them. No, I'm kidding. You can apply and you can go whenever you want.
It's between institutions, so we use it for different things.
It's not like in the Europeans that it's...
That's why I told you yesterday that...
that we do. This is all the departments. There is... Yeah.
We are very nice hosts, like in Greece. And again, thank you for your hospitality. I think they deserve... I think that this is really, really touching, the way you took care of every detail, and it's not trivial. Thank you.
Questions, other questions?
What did you want to ask?
Now first him, then you, then I close.
Thank you for your presentation. If we are willing to create COIL course with those startup course you mentioned,
how to evaluate a startup?
How to start? Where's the entry point?
To do a COIL? We find the...
to combine...
not a startup company, you meant...
a startup course.
How to evaluate a startup? We have the lecture, we have the course, we partner with a few institutions that are interested, and we make a COIL.
This is online, so you can do it. These are online sessions.
We need to it's mostly bureaucratic stuff, and finding the students from your side and the side of the other partners.
You know?
Yeah, I don't know, maybe you have already mentioned this, but do we have any type of special training for the teachers that are doing these tandem courses? Any sessions to prepare or to explain what's going on? Or not?
In general, and especially in light of everything that is going on, you know, now, yesterday I talked about how my school, I will mention this now, it's important. We talked about artificial intelligence and how education should prepare. We have an ethical code. So we have committees inside the school, committee for research, how to encourage our team members, staff members to do more research, because in HIT we cannot get promotion if we don't do research. So we help each other. It's all about teamwork. I was not joking about, you know, this slide that I love, okay? I was not joking. I am really sometimes even forcing people to work together, because it's difficult to do research alone, and it's difficult to think about new ideas. And also training, we have, from the institution, we have training, but we also bring from outside where it's needed. For example, after Corona, I brought someone to talk to us about how to talk to the students now. How to convince them, to cooperate with us. We really needed something in psychology. It was because also the teachers, they were tired. They were tired, okay? They were exhausted, and they needed support. So we didn't call it mental support, but we called it the skills of communication. Coming back from Corona was a challenge. And also, to be honest, also with the teachers, there were some, not disciplines, but they didn't feel like coming as well. So, oh, I don't feel well, oh, I'm going to go to Zoom. Oh, there is traffic, No, in Israel, there are a lot of cases where you can't go to work, so we don't need to look for others. You needed to really readjust. So we brought training. And teaching together, it's more a personal thing, but look, I have three deputies actually, and we all work together to pay attention to the people. It's all about the people. You said it. It's all about the people.
Just last, because we have to make the...
No, I'm just sharing.
Dear Nava, I thank you again for this wonderful presentation and your polite words. Thanks a lot. I think that actually it's not a question, it's a statement. I think from the last presentation of Kostas.
One before the last.
Yes, one before the last. I undersigned the word blended. Okay? So the paradox here is that if we want to succeed, if we want to excel, if we want to take part as lecturers or the part of education and upgrade our level, we have to blend. And I think that your faculty, what you have created, is based in an inspiration that it comes.
But it's not only blend. It's not. But just to make it a little bit more accurate, it's blending without losing your identity. It doesn't mean that now everybody's the same. No, we keep our identity and our specialization. I still hold my specialization, but I blend according to the needs and according to create, again, 1 and 1 is 3.
Look, I would like to comment on this. Exactly what are you doing is the correct thing, but the correct verb is blend. Because otherwise it's integrate. Do we have any chemists here? Any chemists? No chemists? When you who is the chemist? Oh, chemist. When you integrate, you are losing because you are creating a new material. You are losing this identity. With blended, you keep this identity.
So yes, we work together, but we keep our identity, and we try to create something new, also that can serve the purpose and the vision. Thank you very much. Thank you very much.
Wait. Yes. Okay, let's have a break for a quarter, not a half an hour. Take your coffee, come back in order to continue with the schedule. Let's thanks again, I get a question. What is the course? The course Freedom Fighters. So let's continue. It's a great pleasure to have with us a colleague from Vilnius Tech. You can find also very nice pens from Vilnius Tech in the front desk. It's Associate Professor Raimonda Bubliene. She's going to speak to us about something important, very much related with the technology, which are the copyrights and how we can secure, I suspect, the IP and our innovative products, as they are generated from the research. So the floor for the next 45 minutes is like to Raimonda, and the title of her lecture is Copyright Law and Technological Change. So I think it's very, very hot topic to listen. The floor is yours. I mean, about the topic. Please. Thank you very much. Speak close to the hand. And you can use the remote control.
Yeah.
Your phone, and then this is the laser.
Okay. So I think it's better. Yeah. Okay. Thank you very much. Hello, everyone. I'm really happy to be here and to represent my institution. Well, I just shortly inform you that we are the biggest technical university in our country. As well, we have the 10 faculties. I'm the representative of the Faculty of Business Management, and I work as a head of the Department of Law. So today we will discuss how the copyright law was influenced by the technological change, and we will have the short discussion later on. So first of all, before starting my presentation, I would like to point that copyright at the beginning, copyright starts from it's directly connected to the technology. Because the first legal act, it was released in 1710, and actually it was a British statute, British Statute of Anne, and it was about the publishing of books. So copyright law is directly connected with first of all, the first technology of publishing, because when they start to have the publishing machines, printing machines, then arose the question about the protection of authors. And so at the beginning, the copyright law was applied for the publishing of books, copying of the books. Now we have a wide, broad scope of the copyright law. So, first of all, I would like to point that we have, and in legal relations, we have subject and object. Subject are the natural person, as we are all here in the auditorium, legal person, institutions, organizations, and government, and object, everything what is valuable, and of course, money, securities, after that, immovable things, movable things, information, work and services, and for sure, the object of the legal relations is the intellectual property, because you can transfer intellectual property, you can gain the profit, and so on. So everyone has the right to the protection of the moral and material interests resulting from any scientific, literary, or artistic production of which he is the author. So that is the section from the Universal Declaration of Human Rights. And well, in our country law, in our main legal document, legal act, constitution, as well, There is stated that the law shall protect and defend the spiritual and material interests of an author that are related to the scientific, technical, cultural, and artistical work. I'm pretty sure that more or less the same legal regulation you have in your own local law in your countries. So let's move forward, and I would like to point that copyright law is a part of the intellectual property law. But for sure, the intellectual property law is quite an umbrella for the several types of the intellectual properties, of the intellectual property objects. So first of all, copyright. And here I would like to point that copyright protection according the laws now is for the economic right 70 years after the author death. Moral rights has an indefinite time of the period. After that, we have the inventions, so the patents, and the protection for the patent is 20 years after the filing of the registration of the patent. Related rights that are producers of the movies and broadcasting, so we have the term of 50 years. When the work was created, trademarks registration is 5 years and up to continuing to 20 years, design and others. So all objects of the intellectual property have two common features. They always are immaterial, first of all, and they are the property that we might use, dispose, and for sure gain the profit. So what is the scope and concept of the copyright law? So the rules of which regulates realization and defense of the interests related to the creation and usage of the works of science or art and literature. Here I would like to add that copyright law, under the copyright law protection during that technological change, an object for the copyright law protection became computer programs and as well databases. So the object of the copyright law is more wide, and these rights as well have common features as follows. So the subject matter of these rights are being protected from the moment of the creation of them. So the copyright law is unique that after there is a when the author creates a work, copyright law, protection of the copyright law starts from the moment of the creation. If we will compare, for example, with the patent, with the invention, so creation starts after, protection starts after the registration of inventions and patent. So the copyrightable works must have objective form of expression, but not necessarily in material form. As well, here is a quite important point, because it is enough to say that for the author, the work to express it. So what we can see, what we can hear, everything will be considered as already a copyright work, and the rights have limit in time. So as I have mentioned, for the economic rights, we have 70 years after the author death. If we have joint authorship, so 70 years after the last author death, and for sure, the moral rights always stays with the author. They are not we can't transfer, and well, it doesn't have a time limit. The rights have the territorial effect, and the implementation and defense of these rights are embodied through granting of the exclusive rights to use the subject matter of the copyright, but not through the absolute monopoly over them. So, the result of creative activities related with the literature, science, and art, as well as I have mentioned before, computer programs and databases, it is an original result of intellectual job. And here as well, I would like to point that original work doesn't mean the novelty of the work. It means that they might use some additional sources already that were or published, or some features of the work before. And original means that it should be original, but it doesn't mean that it is necessary to have an aspect of novelty. Express it in objective form. So objective form means everything that we can, as I have mentioned, we can hear and we can see. And copyrightable, whatever the artistic value. We all know that artistic value is like a very complicated evaluation, because some great artists that we have in the history, they at the time when they created the work, they were not gaining a profit from the copyrightable works. Well, so the object is copyrightable, whatever the artistic value, because the artistic value might change in the sense of the evaluation in the society. So now I would like briefly introduce the law, the source of the copyright law. And here I would like as well to point that there are the national legal regulation, national legal acts, as well the international treaties, and for sure the law of European Union. The main difference between national and international or European law, for sure it is application, territorial application. And as well, if we will talk about the copyright law, I should point that international treaties as well did a huge impact to the national legal acts of different countries. So first of all, I will discuss the document that is the most important one as international document, Berne Convention for the Protection of Literary and Artistic Works. And you can see that it was really came into the force 1886. And well, I should say that Greece joined the Berne Convention of 1920. Unfortunately, we joined Berne Convention on 1994 as we re-established our independence. So authors shall enjoy in respect of works for which they are protected under this convention in countries of the Union and other than the country of origin, the rights which the respective laws do now or may hereafter grant to the nationals, as well as the right specially granted by the convention. And the enjoyment of the exercise of the rights shall not be subject to any formality, and the enjoyment of the exercise of the rights shall be independent of the existence and protection of the country of the origin. And well, here as well, I would like to mention that already Berne Convention 180 countries joined the Berne Convention, and our national law is designed according to the requirements of the Berne Convention. Next important document that brings the technology into the copyright law again, that is the WIPO Copyright Treaty. This treaty was released after 110 years from the Berne Convention in 1996, and it is a special agreement under the Berne Convention which deals with the protection of the works and the rights of the authors in the digital environment. In addition to the rights recognized by the Berne Convention, they are granted certain economic rights. So it means that after 110 years, we have the more wide application of the copyright law, application for the computer programs and databases. Other international treaty, Rome Convention for the protection of performance producers of phonograms and broadcasting organizations, and it means provision implements the protection for the performance producers of phonograms and for the broadcasting organizations. The convention implements the principle of national treatment, provides the minimum standards of the protection of the related rights, and minimizes the formalities for the protection of related rights. And next document as well important to the protection of the copyright law in the international level, the trade relates aspects of the intellectual property agreement. So it is called as TRIPS agreement, and regulates both copyright and related rights, provides for the national treatment principle, and provides for the most favored national treatment principle. As well, agreement implements protection for computer programs as well for the producers thereof. And now going to the law of the European Union, and here I should a little bit explain the level of the legal regulation of the European Union. You can see that there are 4 directives that helps to regulate the computer programs protection as well, digital single market, and copyright terms, regulates the copyright terms. I would like to point that directives are the type of the EU law that countries, member states should implement into the national law. As for example, during now I think everyone knows GDPR, yes, General Data Protection Regulation. I just would like to mention that directive regarding the data protection was as a directive from 1995, and I think nobody was hearing about this type of the directive. And when it became a regulation that directly applied into the directive and regulation differences, that regulation directly applies to the member states' law. So it means not need transfer as a directive, and well, the protection level of the personal data increase a lot. So the directives, of course, important, and as well we can see that European Union as well takes an importance of the computer programs, because of course computer programs are very important for the industry as well. So, so the protection of the computer programs later on with the technological change became an important point. And here I would like to shortly represent our legal act on the copyright law. As I have mentioned, we have the, as I have mentioned, it is actually, we have the saying that is a copy of the Berne Convention. And it was, came into force 1999. And this law is designed to regulate 3 groups of intellectual property rights. So copyright, related rights, and rights of makers of databases. And implements collective administration of the copyrights and related rights, and means of enforcement and protection of the copyrights, related rights, and rights of the makers of the databases. And here, I would like a little bit more explain the distinguish between the author rights. And so the main objective of the copyright law is to protect creators' individual interests by providing them with the legal means for the control usage of the work. And such interests are of different content. And it is different content for what we want to protect, for what we want to have the protection. And there is distinguish between the economic rights and moral rights of the author. So economic rights is connected with the reproduction, publication, translation of a work, adaptation, arrangements, dramatization, and other transformation of a work, distribution of the original or copies to the public, public display, public performances, broadcasting, retransmission, communication to the public, including the making available to the public of work over computer networks, so the internet. And moral rights that I have mentioned already before, that moral rights is indefinite time of the period. So the right of the authorship, clearly to display the author's right together with the author work, the right to the author's name, and after the making available to the public of the copyright work, we have the presumption that the author who is, whose title is on the work, it is an author, and the right to inviolability of work. So these this distinguish of the economic and moral rights differ that not only on the term of protection, but as well moral rights are not transferred to the other persons. It always stays with the author. And here I would like further to discuss the limitation on economic rights. And I think we all know the citation and making the reference without the prior consent from the author. And law provides for possibilities to use work without the consent of authors. And these certain possibilities are called limitations on economic rights. But for sure, any limitations on economic rights shall be permitted exclusively to the case provided for in the law. It must not conflict with the normal exploitation of a work and must not prejudice the legitimate interest of author or other owner of the copyright. And as I have mentioned, it's limitation on economic rights as well connected with the citation and references, but as well today we have the artificial intelligence question. And I should say that as a teacher, I work with information technology law course, and my students, programmers and information system technology students, they are telling me that they generate approximately 80% of their work with the artificial intelligence. Well, for sure, my students are already fourth-year students, so they have advanced knowledges in the using of the computer programs. So that there we have the question. And now we have a lot of tools to detect plagiarism. 10, 15 years ago, there was no tool in a proper way to detect plagiarism. Today, we have the question of artificial intelligence and detection of the artificial intelligence at the students' work. And well, I should say that there are practices that as well uses some universities that the student should clearly indicate, as we indicating the citation, clearly indicate what, where, and when, for what purpose. Oh, 5 minutes? Okay. For what purpose the artificial intelligence was used. So there is no still legal regulation, but I think that it's always better to have the regulation and even not a best one. And so I will continue to the limitation related to public demands and fields of education, information, and culture. And it shall be permissible without the authorization of the author or any other owner of the copyright to reproduce a relative short passage of published work or a work made available to the public, both in the original and translated language, in the form of the quotation in another work, provided that such reproduction is compatible with the fair practice and its extent does not exceed that justified by the purpose. And it shall be permitted without the authorization of the author of work or any other owner of copyright in the work and without the payment of a remuneration, but mentioning when possible the source of the name of the author to reproduce for non-commercial teaching and scientific research purposes a short published works and short extract thereof, provided that this is related to study programs and does not exceed the extent justified by the purpose, as well as the work kept in the publicly accessible libraries, educational establishments, museums, and archives. And limitation-related business demands of information technologies, so it is permitted to carry out without the authorization of a holder of copyright the reproduction of communication to the public of a work in connection with the demonstration or repair of equipment, as well permitted without the authorization of a holder of copyright to reproduce adapt computer programs on certain conditions. It might happen when we have the some mistakes in the computer programs. It is permitted without the authorization to reproduce the code of a computer program on a certain condition as well. And now a little bit about the concept of the databases, another important object of the copyright law that is connected with the technology as well. So it means compilation of work data or any other material arranged in the systematic or methodical way, and individually accessible by electronic or other means, except for the computer programs used in the making or operation of such databases. And rights of makers of the databases also are called as sui generis rights. And databases may be protected as a work under the copyright law, and database itself under the sui generis right. And a person may become an owner by selecting, arranging, verifying, and representing the content of the database. Has substantial qualitative and quantitative investments, and it has made substantial qualitative or quantitative investments in creating of a database. And now the topics for the short discussion. I would like to ask the microphone if it is possible. Yeah, so the first question for the audience, illegal download of music or movie is just as bad as stealing them from a store. What do you think?
Yes, I guess so. It's the same.
Mm-hmm. Why?
thing.
Why you think so?
Because we steal authors' rights and money.
Mm-hmm. Okay, first of all, the value. Mm-hmm. Okay, do we have some other opinions? Yes, please.
Well, I guess it depends on the point of view. If we are looking at the intellectual property rights, of course, it's the same. If you think about the value and the economical impact on the players around, I believe it's a bit different. But stealing from a physical store, I believe, involves more costs than stealing from online.
Mm-hmm.
But ethically, of course, it's the same.
And the same. Well, it might cause a criminal liability in both cases as well. Mm-hmm. Do we have more?
In my opinion, it is illegal to download without subscription to a platform that has the license to use the work of others.
Mm-hmm.
It is like to take an image from a paper, to copy to my presentation without making the reference.
Mm-hmm.
So you are using the work of others if you don't have, if you know the material is not open access, so it has this open science like the publication authorization. If you don't have the authorization through a platform or from the owner, I think it's illegal.
Illegal. Okay, thank
Even
you.
you can see this in the market. For the DJs to play specific music, they pay an agency in order to be able to use and play the music of the artist.
Mm-hmm.
Technology is always an issue, and I start being illegal when I was in high school, when I took cassettes and we start copywriting, copy a cassette with music from LPs, or then CD came, we continue with the same. And then Amsterdam was created and we start downloading. That was completely illegal, all the actions. And then, and today we have YouTube. And musicians decide that it's meaningless to try not to steal it, so they find a way to promote their music. There is a platform that you can buy, of course, but you don't need it because YouTube is always available, and now we all have data, and we are doing this legally. That was changed, the intellectual property has changed by technology. I'm not sure that the artificial intelligence can change a lot of things, because finally, if you don't know your topic and you cannot write, you cannot ask in artificial intelligence and give you questions. Finally, I believe that the last one, it's something I cannot understand it. You have the answer probably, but human being has in his feelings, in his life, a way to try to escape from borders and from limits. So I've realized from all those I've said that all the time we can find something to cross over the intellectual property law, and that will continue in the future, and we will create something new, and we can find a new way to cross over it. So for all this question, I think it's matter of human activity.
Human being.
They will never change.
Harista?
I've got a question to you. If I said to ChatGPT, write a poem about love with 13 syllables and rhythms, A, B, B, A, and he would wrote it, who is the author? Me?
Author might be only a natural person. Only a natural person.
But I didn't write it.
Yep, so you should not you should not post it as you are an author of this creation.
Okay. Thank you.
Well, second question, why has a technological change caused problem for the intellectual property law? Do we have some ideas from the audience?
Why has a technological change caused problem for intellectual property law?
Yes.
I think that my colleague Tsikalakis
Yes.
has approached it.
He went via all the questions, but maybe we have more ideas?
More ideas? How technology has changed caused problem for intellectual property law? Please. Are you a lawyer?
Well, I don't know if I got the question right, but with this technology change, you can cheat in your bedroom very quiet and with nobody around, so this facilitates things.
Okay, thank you. Do we have some more ideas? Well, so let's go to the third one. Why are developed countries more likely than developing ones to sign international intellectual property agreements? What do you think?
I think it's the structures, the structures and the tradition of the state. So they have pilot and they have experienced this kind of, let's say, challenges earlier or similar challenges. So they have the structures and the mechanisms to react faster in a more holistic way. This is my opinion.
Okay.
And this has, and this builds also the culture among the citizens, because it's not only the law, it's our culture how to behave to a specific.
Legal rules are affected by the culture, by the religion, and other norms of the political norms and so on. Do we have more opinion? Well, thank you for your attention.
There is from a student, which is important for us.
I think that it is a problem in our world, and actually there are different types of problems. So when you are a developing country, you have more problems, and probably they are more important to your eyes. So they do not decide to act on things, like, for example, property agreements. They do not care about these things, the developing countries. They are not yet to reach this level. I think this is the difference.
Yeah. Okay, thank you. Thank you. Well, as well, developed countries, yes, they are over the protection of the economic interests as well. So, Haristo, if you have more questions, I will be happy to answer.
Thank you. Let's thank the speaker. You did our life easier with your questions. So it was very good. I had a question, but I will ask you, later on. Let me call to the podium the next speaker. It's a similar, I think, from a different approach. So let me invite Cristina Maria Ferro de Oliveira Gomez. You should explain to me what is the first name and the last name. The last was enrolled in the doctoral program at the Faculty of Law, Department of Labor Law and Social Security at the University of Salamanca, Spain. Dedicated to the program, I cannot pronounce this, La Regulación del Mercado de Trabajo, and holds a diploma of advanced studies with mention of outstanding and excellent. Right now, Cristina is a professor of law performing functions at Polytechnic Institute of Coimbra as an adjunct professor. The talk that she's going to present to us today is the Platform Workers Directive and the protection of personal data within the scope of workers' legal sphere. So the floor is yours, and thank you so much for your contribution. You should speak close to the microphone. Okay. You can use the remote control. All right?
Well, thank you for being here and for listening to me. My main interest is labor law, and particularly about safety and health issues and about occupational accidents. But I also have investigated the theme of data protection. And today, what will I talk about? I will talk about the proposed directive, proposed in terms of digital labor rights, and the risks of artificial intelligence. Well, in the first case, we have to know that digital platforms is understood like we have a gig platform economy. It's estimated that in terms of economic issues, digital platforms have developed economically in 500% in the last 5 years. So it's important, the existence of digital platforms, not just in a point of view of the enterprises, but also in the point of view of the consumers. But the problem in these digital platforms in matters of occupational risks and violations is that those digital platforms, what they do, they monetize illegally the tasks performed by workers. They violate privacy rights. They put in risk their right to liberty and their right to autonomy. We have to think, and for example, the digital platforms that involve private transportation, and we have to think what is the labor that is performing that task mostly it's migrants or it's particularly vulnerable workers. So the digital platforms, what do? They use an algorithmic management to control the worker, to monitorize the workers through GPS, and that's illegal as we know. They make pressure on the worker in order to deliver the task, perform the tasks in the most most uncostly way and the most faster way. This means that ILO, the International Labour Organization, it doesn't put in crisis the importance of digital labor platforms, but what does the ILO says about this? It says that this crowd workers, they are in risk of, they don't have access to their, towards their data. For instance, we can, these workers are impelled to install softwares, and these softwares process their data, collect their data, inclusive personal data, and what happens, and monitorize the worker illegally in his breaks, in his productivity, and this is the most problem of monitoring systems and decision-making systems. We have, in a point of view of European Union, we have regulations, and the general regulation of data protection that is identified here, establish in matters of data protection several individual rights. We have the right to be informed of what data is being processed, the reasons for that that treatment. We have the right to assess the data, and crowd workers in this field have the right to assess the data when monitorized systems are taken in place. They have also the right to data portability. What does it mean? It means that the worker has the right to transmit the data subject, in this case the worker, has the right to transmit, to receive and transmit his data to another controller without opposite of the first controller. This also doesn't take place in the specific work, digital labor work. We have also, we and the workers, the right of data erasure, the right to be forgotten, and this general regulation data protection established here, also the right not to be subject to a decision based solely in automated systems. Therefore, this means that in the decision, automated systems, monitorized systems, and in matters of decision-making systems, there is the need of human intervention, taking into account the risks that EA presents to the workers. I will talk about this proposal of the Platform Workers Directive, and I will complete this reference with the Council approach. Well, this regulamentations have influence in Article 8 of the Chapter Fundamental Rights of the European Union. In matters of data protection, they have the right to assess the data that is being treated by monitorized systems. We have also the General Data Protection, and we have a proposed Artificial Intelligence Act. These diplomas don't regulate specifically digital labor aspects. Well, we have to take in account the Article 5A. The Article 5A says that it is prohibited from digital platforms to process data over the emotional or psychological state of the worker. It is said also that automated systems cannot, and decision-making systems cannot monitor the worker when he isn't performing a task. And this happens in the reality. In the Article 6, taking into account the objectives of this proposal, the Article 6 grants more transparency and fairness to the data protection rules. Or it says that crowd workers have the right to be informed inclusively in an electronic way, but that they have the right to be informed of the use of automating monitoring systems and automated decision-making systems. And it gives the right not just to crowd workers to be informed of this information, but also to their representatives. There are limitations about Article 5A. As I told you, this directive prohibits the processing of personal data, but it doesn't. The main question in this article is that it doesn't ban definitively the collection of that data. We have to take in account that crowd workers don't have the digital platform is the owner of crowd workers' data. We have to take in account policies like price rate payments. Let's think that are common in USA. Let's think that in food delivery, for example, the crowd workers, the digital workers, they have to do the task in a minus expensive way, and they are monetized in that question. What are the consequences? The consequences is that if they don't fulfill the rates of the digital platform, they are just logged off, they are just dismissed. And this is this kind of policies put enormous pressure, present enormous risks in terms of safety and also security, because they have more accidents, they disregard the safety rules, and they are subject to psychosocial risks. And this article of this directive is it's welcomed truly, but we have one great problem respecting the article, is that it prohibits the processing, but doesn't ban the collection of these data. Well, Article 7 and Article 8, what do? They put the obligation to the digital labor platform to monitor regularly and evaluate the risks that monitoring systems and that decision-making systems can pose to the crowd workers. And for that reason, indeed, it's needed the human intervention. This means that a person with responsibility, capability, with independence can rewrite the decision taken on terms of monitoring, monitoring and decision-making systems. Also, about the decision-making systems, we have to think that this is an algorithmic that is taken, that is designed, trained to take the significant decisions. Well, the platform workers, what I'm going to tell you doesn't happen now. The platform workers will have the right to explanation of the individual decisions that affect them. This is good also. This grants more transparency, more integrity to the platform worker. But to salvaguard, to make this possible, to the fairness and the transparency, what happens? It's needed a human intervention in the decision-making systems, about the decision-making systems. The platform worker has the right to be informed of the facts and the fundamentals of the decision, has the right to contact a person designated by the digital platform to explain those facts. And the digital platform has to have human resources that permit that decision is legal. It's not discriminatory. It doesn't imply discrimination. Because what we attend in reality is the algorithm puts in order the discrimination of the workers, of the crowd workers. The example that I gave before, the policies of price payment rates, it's in the consequence, they are dismissed. This is a major problem among us. Well, Article 8A, with Article 5A, regulate the rules about health and safety. And Article 8A establishes that the digital platforms have to evaluate the risks of automated monitoring systems and decision-making systems in matters of, among others, economic risks, work-related accidents, and also psychosocial risks. They have to put in place the adequate safeguards for these monitoring systems and decision-making systems, and they have to adopt preventive and protective measures. This is we welcome the scientific view welcomes Article 5A and Article 8A because as I said and tried to establish these workers have poor conditions, and we have to take in account that the most of these workers, this is the only way of survival, and they submit themselves. I'm talking about minorities, I'm talking about parts of the society that are particularly vulnerable. And what happens in this matters? They are monitorized while working, while in their breaks. They are discriminated by all the algorithms, and there's psychosocial risks. They are put in pressure, their emotional and psychological state is taken in account, and this is not fair, as you know. This is not fair. This has to be regulated. Well, 5A and 8A are articles that in occupational safety and health are very important, and that we welcome this reference. Then we have Article 9. Article 9 finally determines that the workers' representatives, they have the right to, before the introduce of substantial changes in the use of automated monitoring of decision-making systems, they are consulted and they can give their opinion of that monitoring system or the system of decision-making systems that introduce substantial changes. This article, in particular, it is necessary a reference to occupational. Also, in OSH. Well, we can say that this directive, in a general way, makes reference, reinforces the need of transparency and fairness in data protection, reinforces the right in matters of data protections, assesses the risks of algorithmic management, and we know that EA has risks. It's not the use of EA, believe me, it's not just, it has advantages, but it has risks, and there's the need of human intervention. And this directive addresses for the first time, and that's welcome also, the psychosocial hazards and the psychosocial risks. We have to take in account that we have the general regulation on OSH at the European level, and that refers to psychosocial risks, but doesn't involve the notion, doesn't involve specifically this matter. And we at the European level have two framework agreements about psychosocial risks, one related to stress and the other related to bullying. There's the need of this article, the Article 8A and 5A that I talked about. There is a need of definition, of concrete definition in the ambit of digital platforms, of psychosocial risks, and the need to reference the obligations that digital labor platforms have in this matter. I don't want you to think that I'm just criticizing this proposed directive. No, it's welcome. The crowd workers, the digital labor workers, don't have because it didn't enter in force. Okay, thank you. It's welcome, but it has also fails, and the fails that I addressed to you will be probably developed by me in a project, a European Union project. I have interest in this matter. Well, the fails, the critics that I have about the articles, I talked about them, and I hope that you understand the risks that digital platforms workers have in this matter, and the importance of regulation through the risks of algorithmic management and monitoring systems and decision-making systems also. Okay? To finalize my presentation, we have, I'm going to talk about a comparative point of view. In Brazil, we have the Brazilian General Data Protection Law that says that the processing of personal data cannot be discriminatory. And I told you that in fact, this fact exists towards the algorithmic management and monitoring. France, we had amendment of the Code du Travail, the labor code, but it applies just to self-employed, and I'm talking about workers that have an employment contract. Another question that arises about the stability of the contractual relationship is that most of those workers don't have an employment contract. They don't benefit of the protection of labor law. In Italy, Italy, Bologna in special, regulated this matter of the risks that digital platforms workers have in the Charter of Fundamental Rights and Digital Workers in the European context. The rules that I told you, this chapter regulate these rules and put a prohibition of processing highly sensitive data. Well, I'm available for any question if you want. Thank you very much.
Questions?
No?
I have one.
Yeah.
Curiosity. So I have a question to you and also to the other colleague that you were talking about legal related issues. I mean, how uniform are all these issues and important issues that you have mentioned in both of the presentations across the whole Europe? Is there any European approach, or we have very much differences from countries within the European country core members? Because this complicates the situation, I think, in the majority of the cases. About
Digital platforms work, and we don't have the uniformization. It's a new regulation that will make force internal, national, at the national level. There is the need to develop this matter and to regulation bills. Yes.
This is very strange because we live in the digitalization era, which means that everyone is interconnected and still we have the national barriers.
Yes.
And I mean, as a legal people, why do we have these national barriers? What is the difference? For example, for data protection, you made some questions before. I mean, you're addressing other issues. I mean, the data protection should be the same in any countries. So why do we have different legislations about the same thing in different countries?
No,
and it's not one.
About data protection.
It's the same that, someone asks, about regulated professions. Engineers, they should know to build, for example, bridges. So why the civil engineering assessment to receive these technical competencies are different in Greece, in Portugal, or in Lithuania? The same happens with the law. Cannot find, you know, I cannot find as a citizen, European citizen, a reason for this. You are an engineer, for example, engineers are doing a lot of things. But civil engineers, you should know how to build bridges. It's the same way.
About data protection, we have the regulation at the European level.
The fundamentals are the same.
But some structures of work at national level are different. Yes, that happens.
I think that we should overcome this in order, because all the prohibition, especially also in the European universities, they would like to build European university alliances. But there is no a legal framework how to overcome, you know, national obstacles. The national governments, they participate in the European activity, and at the same time, you know, these, you know, barriers, they are not lifted. You would like to build a European university. Should be a pathway.
Yeah.
I think that this is, I don't know, I don't want to express myself. Do you want to comment? No? Okay, I'm a good lawyer. No comment. Okay, so, and what are your suggestions? Is it possible these national barriers to overcome or to lower this? Because otherwise, we will never have a unification. You see the Bosman law, how much change, you know, the integration of Europe. Anyone now can work in any European country, but at the same time, at the institutional level, we cannot collaborate fully. And this is not culture to protect your culture. You can protect your culture, but you should also promote the collaboration.
Yeah.
What do you think?
I think that, for example, directives are transposed to national level, but there are other problems. There are specific issues that need special treatment, not only at the European level, but also in national level.
An example?
Portugal, for example.
No, Portugal is an example.
Psychosocial risks, as I told you.
Yes, please. No. I will come and then.
Okay, I just would like to have one comment that even we are the lawyers and we don't agree on certain legal rules, we don't interpret the certain legal rules the same. So that maybe it's as well a question, because even if about data protection, for example, our data protection inspectorate is a very, very strict institution. I think so that as I have other practice during the European Union member states, I think that it is variety because the interpretation of law is different. So in that case as well, it should be interpreted the same, but unfortunately, we have one case might be decided by the court by one judgment, and we might have another the same case by the appeal judged by in a different way. So maybe that is quite an answer to your question.
Yes,
But football unites everyone, overcomes any barriers. Yes, or basketball. Thank you. Just a moment, we have one comment.
I just want to say that this is not so simple. Even in countries like United States of America or in Germany, which are federation states, there are so many differences between many differences in other faculties. It's not so simple because the market is doing its first, and then the laws and the recognitions about what
But say the markets, they would like to facilitate their work. They would like to move very fast, so they don't want barriers.
But it's not so simple, you know, because every state has its own dimensions and its own priorities, and so in many faculties they provide that, in another state they start it, and it's complicated story. It's not so easy.
No. I mean, you are right from your point of view. Then we should stop to speak about European values integration. So they should not speak about this. If this is the case, okay. I'm in Greece, you are in Lithuania, you are in Germany, there's no problem. But when they speak and they provide so many funds for European integration, they should provide, the tools for this European integration. Otherwise, European community will be, in a few years, a failed as well.
I'm with you.
Yeah. I like your pen. I will take another one. Any other question? Please.
I would like to say that who participated in discussion, there are the virus. It's our virus from Vilnius Tech. Actually, I'm supposed to show you all the possibilities of the biro, so you can use it as a biro. But if you would like to touch some screen, you can touch by it. Here is a screwdriver that you can use. Oh, yes. Yes, and yes, and here you can clean the screen, and of course there is a ruler to measure.
We will measure. How much? So, I give 10 euros.
So this, excuse me, just a moment. This closes very nice this session. Technology again, even to the gifts. I would like to thank the speakers for the session, both of our dear colleagues, and see you 2:15. Try to be here. It's very important. Okay, bye. So, let's continue our session after the lunch break, which is a challenge regarding the participation. But us that we are here, I think that we are going to be very lucky, and we are going to learn a lot of things from Professor Alexei Rasov. He's an associate professor in the Department of Entrepreneurship in Vilnius Tech in Lithuania. His talk is entitled Artificial Intelligence and Big Data in Education, New Frontiers and Opportunities. So I would like to thank Alexei for his participation and contribution, and we are looking forward in order to listening to you. Alexei, the floor is yours. Please speak close to the microphone, and this is like the forward, backwards, and the laser. Thank you, Alexei.
So, thank you for the opportunity. Hello, dear participants of the forum. The structure of the lecture. I will introduce myself through the prism of latest research and development projects. I will talk about my professional experience and field of expertise, highlighting how we can collaborate and what possible fields of collaboration you can expect from me. Those latest research and development projects provided me with big data in education, and I will dive deeper and explain what types of data it may be, what characteristics they have, and how we can find some meaningful insight from this big data. And finally, I'm going to talk about opportunities of collaboration with other members of ATHENA consortium, and especially applying for Horizon grant. Now I'm preparing such application, and I'm looking for international partners. So this is it. Talking about my professional experience, it's not all projects. Actually, my professional career started in 1991 as a programmer. In 1993, I opened software development company, and the company developed software for accounting and management. So usually it was commercial customers, some government organization, trade union, bank, retail network, and so on. But I never discontinued my collaboration with academics. So in parallel, I had my bachelor education and so on, PhD, theses, and so on and so forth, and opened department in university, and that's it. But strangely enough, big events make it happen that I come across the topic of big data in education. Previously, before this project, I never touched this topic. I was tasked and implemented projects in electronic commerce, electronic government, and other projects. And you know, when I started programming and developing software, I quickly realized that it's boring just develop software that does only what you hard written. Like, if all those conditions true, do this, and that's it. And this is why I came across artificial intelligence as often referred topic during our meetings. So I was thrilled how to make program create new knowledge, make its own decisions, not only those hard written. And because of that, For example, when you deal with some customer like retail network, in 1994, Shoes Retail Network asked me to develop software for managing. And those customers usually they talked in different language. They did not understand the full capacity of technology. They just ask you, you see, we're growing very rapidly. Now we had only one store. Now we have 36 stores. And we even don't know what stock assortment we have in each store. And we even don't know what assortment we have in distribution center. So we need to conduct inventorization every month and face with a lot of challenges. So we're growing so rapidly, we cannot keep it with our paper managed accounting and so on. But when I listen to such customers, I start to thinking what's beyond of such needs. And it led me to the skill of understanding business model and understanding not customer said, but what he actually or she want, or what may benefit the business, what's the real problem, not only accounting. And the same skill I'm trying to develop in students during my courses. Business problem understanding, data understanding, and so on. So, the solution I came was the system that decide what assortment to buy for the whole retail network and where to send it. Because you see, footwear differs by sizes, by colors, by styles, and in different regions, there are different margins, meaning different prices. So, and the different inventory turnover, meaning you put in €1 in the stock, the same color, the same size in one shop, and the speed of gaining cents is different. And the system can predict and decide for you where to send stock to earn as much money as possible. This was the first time I came across artificial intelligence task. And it became my PhD thesis, first of my PhD thesis topics. So now we're reaching the point of those educational data mining and learning analytics projects. Strangely enough, I came across the topic because of the war. In 2014, I was Vice Rector for Education and International Relations in Russian University. And as I prepared for rector election, I visited rectors' councils, government meetings when they invited the leadership of enterprises and universities for some purposes, and all director who was at the end of his professional career, he just was comfortable that someone will visit instead of him and only report, for example, 4-hour meeting. He don't want to sit here, and I was lucky to visit such meetings and only report after meetings that what happens and what they decide and what I talked about. And it was like slight possibility to introduce myself to wider community. If my team will win the election, they will have like seamless strain of events. So I already participated in those events, and I only changed the status. But in 2014, regional government arranged organizational meeting to organize big 40,000 meeting on the main square of the regional capital. This meeting was dedicated to support the war. At that time, Russian army unofficially already was on Ukrainian soil, but it was against the law, and it was even not expected by population. Nobody think about this and knows. And Kremlin said that you need to organize such meetings throughout the country. We were invited to government, and they just distributed the papers, like one, it was the names of organizations, industrial enterprises, and for example, after our university was written, 400 students have to be present at the meeting. Next paper was the map of the main square, where they can stand, have to stand. And the third was the banners, what they need to hold, supporting war policy of the Kremlin. And this has triggered some events. And after I refused to provide my university students to such a meeting and published the article against the war, I have to pack my things and left the country. So at the start of the September 2014, I was in Vilnius Gediminas Technical University, meeting with my vis-a-vis, vice rector of the Vilnius Gediminas Technical University, Asta Radzevichine, and I asked her, is it possible to employ me somehow in some position in the university? And she is kindly agreed, and I start all those, how to say, start new life. So, from that point, I start life as a Lithuanian. Now I have Lithuanian citizenship granted by president and so on and so forth. So, and you see, when you move into a new country, you don't have industrial partners for projects, you don't have anybody. And I start to send letters, like I figure out, okay, there's a big internet store, pigu.lt. I send the letter, I can create for you assortment management system with artificial intelligence. Maybe you're interested in. And I start writing and writing letters to all possible industrial partners. And guess what? What result I get? Oh. Yeah. So any suggestions? Any guesses? Nobody answered. So I wrote and wrote letters, and years have passed, and they just maybe figure out someone even barely speaks Lithuanian, just starting to learn the language, and who is that strange person? And finally, after a year and a half, I sent the letter to National Electronic School Diary. Do you have electronic school diaries in your countries? Do I need to explain the business model? No?
Can you please elaborate what is this electronic?
So the basic model in Lithuania started in 2008. It was first of such system created. It's a commercial company serving hundreds of schools, hundreds of thousands pupils, parents, teachers. They provide service to store grades, homework assignments, messages from teachers to parents, and all that stuff. So you see,
learning management system.
Later, no. Later they start initially. initially they start like only diary. After that, they start incorporating e-learning possibilities and increasing their functionality. Yeah, and you see the basic idea that one school cannot capacity to create good IT system. Even maybe 10 schools joining together don't have such funds. But commercial company, professional IT company, can create it for the whole nation, for example, or even provide the service for another Baltic countries and so on. So when my children left for school, my wife can see on her phone in the application, they're now in class. Or, for example, and for example, if the teacher marked late for the class, my wife see it exactly, or even miss the class, and she can call to the son, "Where are you? You left for the school. Where are you now?" And when my daughter got some grade in math, wife see it exactly at the same time grade introduced in system and so on and so forth. So starting from 2008, now it's only 2 such competing services in Lithuania. They collected big data on all activities, everyday activities. Teacher generates hundreds of events, even thousands of events when he introduces grades, attendance information, and so on, writes messages. And so I provide them with several ideas for research and development grants. For example, booking.com for non-formal education, meaning if you already have hundreds of thousands of pupils and teachers, why not to sell them non-formal education, tutors, courses? You already have their performance in math, physics, foreign languages. You can just develop recommendation engine and recommend better tutor to improve their learning results in math or in physics or any way, or even some sport clubs. So there is no such booking.com possibility worldwide, so it's worldwide innovation. Booking.com solves the problem for hospitality industry, but not for non-formal education. The next idea was Google.com for school graduates. Why not to sell study programs in universities for those graduates, depending on their performance in school, their individual characteristics, and so on and so forth. So system may predict many events like probability of admission, probability of dropout, even employment probabilities, and so on. So this is how I start to develop projects. And it provides me with a lot of data, for example, clickstream data from those electronic school diaries. You see school marks, attendance, and so on and so forth. Data from Lithuanian universities, the same, maybe similar information. Contract employment, self-employment, unemployment data to predict future career trajectories. Because if you pick this study program, you most likely will go this trajectory. If this, and so on. So in order to predict it, I collected a lot of data. What comes with the data? I start to discover it. It's possible to predict learning result, burning out or fatigue teachers and pupils, conflict between teacher and class, for example, tendency to unequally evaluate pupils. You see, this is the distribution of pupil efforts and results in physics for particular teacher of particular school, and they mostly mix. You see, so green and red dots are mixed. This is another teacher from another school, and they are not mixed. It indicates some bias from the teacher. I'm not talking about what bias, but nevertheless. Another thing, it's employment agency information. You see, Lithuanian universities has very successful study programs with unemployment rate near to 0. But at the same time, not disclosing the names of universities, but believe me or not, this is the same universities from the left table. They has those study programs from the right, with unemployment rate near to 1. So they, you see, they simply produce unemployed people. It creates a circle. Sometimes government financed study places on those study programs to get more unemployed people and to spend more money to pay unemployed people.
So the findings here is like they are graduate students find a job not related to their profession.
They applied for unemployment. There's a special, like it's not very many study programs, but they has such study programs, and this is particular indicator calculated after 1 year of graduation. If a student after 1 year of graduation still didn't manage to find the job place, it's student accounted for unemployed.
So let's the first row. You have an unemployment rate 0.007, which means that he's going to get employed. And then if you continue the same line, you have the D in the other side, 0.996.
Yeah.
So what is the relation between 0.007 and 0.996? It's the opposite conclusion.
Yeah, because it's another study program. From the names of universities the same, names of study programs is different, yes. And they're closed. I don't want to damage their them image, and I just cut the data screenshot. I just deleted names of universities, but the same names of same universities, but only different different study programs.
Okay.
And what it tells us that universities simply don't possess study program management capabilities. They don't calculate study program life cycle. When study program go into declining stage, they even don't realize it. And study program became Walking Dead study program. And it still work, it still received government funding. Because of that,
I have a question here. So, you have a study program in Lithuania that is starting to become a Walking Dead study program.
Yeah.
But how do you know that this is not a national issue, but in international level, this study program will flourish?
It's only data from National Employment Service.
Yeah, I will give you an example. During the economical crisis, the technology sector in Greece, you know, it had a crisis. But in the global level, in the European level, it was not an issue. So a study program in Greece related to the sector should probably has high probability to become a Walking Dead study program.
No. I know exactly the names of study programs because it's not IT study programs. Walking Dead, it's not.
Yeah, you know
okay, I can name several.
No, I don't want the names. My question is.
I can provide.
No. Probably I have not understood well. So my question is the following: you have a study program that in Lithuania is a Walking Dead study program. Is this the case in the European level?
I don't have data from European level. I have only national level data. And that's it. But you see, it's specifics of those study programs, actually. And their skill sets they developed. Okay, so the next step was to collect data from LinkedIn on skill sets of alumni from each study program. And I need it because you see those descriptions of the courses are written in completely another language, and those skills written in university, they not cope with labor market, but skills written in LinkedIn, they formulated by labor market. And all vacancy data from LinkedIn, when employer search for employee, he formulates exactly what skills he expect or she expect from employee. So I collected data. It corresponds to Costa's presentation. You said that you provide possibility to choose skills or learning results, not the courses. I provide possibility to choose professional career positions, but not study programs. It looks like in prototype, pupil from school can pick future employment city, only two, Kaunas and Vilnius. And excuse me, could you make photos? Photos of me speaking. Okay. And if pupil picked, for example, Vilnius, the next question is industry. For example, pupil picks finances. It means later pupil provided with vacancies from LinkedIn. For example, this bank search for that position and so on and so forth. Pupil can read what bank provides, in-house fitness, salary, bonuses, and if he like, he just picks this position, collect those positions, and after that my algorithm can calculate the probability of the study program, develop required skills for desired job. It's like know-how. Okay, I will skip this data from Lithuanian universities. One of the example, you see this job is running on the server. This is the IP of the server. It received data from electronic school diary, meaning what is the country of origin, it's female, she will be admitted to university at the age of 19. Her results in different school subjects following and so on and so forth, it's continued. So it's some data from electronic school diary. After that, system picks data of universities, those tables. Each row in table consists information of particular study program. After that, it picks forecasting models of admission to particular study program, dropout, number of fails, number of retakes, and so on. Employment, unemployment, and it sends back the list of recommended study programs with predicted employment probability and other dropout probabilities and so on. So it's individually tailored, the list of recommendation to particular pupil. And that's it. What other possible areas of using such technologies? So direct marketing for target auditory. Such system can attract those who most likely will be admitted and not drop out. It will lower dropout and fails, and it can provide study program life cycle monitoring, study program market position monitoring for universities, what they lack today, and many other data-driven decision support services. Other application, artificial intelligence assistant for university applicants. So such Siri on the website of university. If it's not national-wise, you can just introduce your grade manually. It will not be sent via internet, as in my previous example, but it still can calculate different probabilities and so on. This is the incoming call. It will be open on 4th of October, and the money provided for one project from lower bound 2 million to 3 million euro. And I'm looking for partners. I want to extend such research and such projects in European level because of it's strongly encouraged by Verizon. So I need such partners who can connect, for example, to their employment service, get similar data, and develop the similar services for school graduates, students, to improve their career, to improve their transition to labor market. So please do not hesitate to contact me. Okay, so this is, I tried to formulate several requirements for the partners, and this is one of them. You see, ability to collect, at least collect necessary data. On the right, you see the message from the head of the department from State Data Agency, Lithuanian State Data Agency. So she saw my presentation in National Education Forum, and she asked me for consultations. Now they tasked with joining all data. So all data from labor market, from schools, from universities, social service data, all be joined in one place. I had to collect it from each source, and after that try to combine it together. But now, and it's unstoppable, it's not only in Lithuania, you see, most likely if it's not started in your country, it will be, believe me or not. So it's information age, and now they, in the process, they still not joined. There are two different electronic school diaries. They have not very similar business models and structure of the data. They collected some data, but they don't join yet. But next year, when the project, Horizon project, will start, they most likely will have all data collected and joined. It's provide new possibilities, not even mentioned in my today's talk, because the talk was named New Frontiers and Opportunities, and I told only about few of them. You see, it's impossible to talk about all those opportunities provided with big data in education. When we have all educational trajectory, all career trajectory of each individual, we can do everything. Thank you. For your patience.
Thank you for your performance. I would like to ask, who is the owner of the information, of the elements of these data, and what about RODO, like, you know, safety of the information?
Talking about GDPR issues, those electronic school diaries are subject to constant audit from government on GDPR.
and owner of data is those parents and pupils. But when they create their account in electronic school diary, they sign that they allow to use this data for some purposes. For example, learning analytics, some smart suggestions, and so on and so forth. So,
and Dave, please.
And what about the final database that will be created in the project? Because I understand that the technology that will be developed on certain database will pick up from there and will continue to use data, more up-to-date data, right?
You see, I'm actually not interested in storing data. I'm interested in storing up-to-date forecasting models. Because of that, I need periodic access to actual data. Generate forecasting models, and that's it. I don't need to store all that data.
So, in the project that you are proposing, you would like to compare the situation in Lithuania with, you know, other, or to experiment what are you doing in other countries in order to have the European.
Maybe develop such prototype not on the national but on the European level.
All right. So, what are you expecting from there? What is like what is your motivation apart of extending your work? What you would like to see? You would like to see some data that they are going to compare the situation to the three different European countries. What you would like to do with this?
I would like to develop this system that may advise, for example, Lithuanian pupil, Lithuanian school graduate, to take your study program.
Correct.
Because of his future career expectations and so on.
Yeah. Or that the Walking Dead programs in Lithuania probably are not Walking Dead programs in Greece, and they can come and work there.
It's not working in this case. You see, maybe declining study programs, maybe not declining in Greece, but Walking Dead, it's Walking Dead. It's already finished.
Everywhere. Oh. Any other question? So, if you would like to participate in this Horizon project, you should contact our colleague. I think that we have expressed as a university to participate. George is here, who is the interlink with the market from our side. And we would like to thank you again for your interesting presentation. Thank you. So now I'm very happy to introduce on the panel one of my colleagues and friends, Professor Dietetics George, who is a lecturer in the Department of Electronic Engineering. George has an extensive experience in linking our curricula with the market. He's going to speak about another activity that we run in the ATHENA, about fiber optics communication in the ATHENA Photonics Hub. So, George, the floor is yours. And thank you. Αυτό και μετά αυτό. Το μίτσο. Εντάξει, μόλις έχω αυτό. Εντάξει, okay. I will see here. What's happening? We should stop the next time. No lunch.
Well, thank you, Kostas. Hello, everyone. The aim of this presentation is to link our activities in fiber optic communications with the greater context of the ATHENA European University, and more specifically about the ATHENA Photonics Hub, which is an idea inspired by friend Kostas, Professor Petridis. Let me.
George, you should be close to the
Yes, okay, you're right. Yes, okay. Fiber optic communication is an application area of the greater research area of photonics, and here you can see the various pillars or the various specific application areas that are related to photonics technology. And you can see, for example, the digital infrastructure that is based on photonics technology, and more specifically, edge computing, metaverse, augmented and virtual reality, and high-performance computing and quantum computing. A second pillar is that of industrial systems in space and defense, automotive industry and mobility, Industry 5 and manufacturing. And the third one has to do with health, renewable energies, agriculture and food, which is more or less related to the department here in CITIA. All these areas are interlinked with European policies, the corresponding European policies, for example, the European Green Deal, the European Industry Strategy, and the Europe for the Digital Age. The importance of the photonics area is showed here by some representative statistical data. For example, there are around more than 5,000 small medium enterprises and then, of course, a number of larger companies that are involved in this, in the whole photonics ecosystem. And these companies directly employ over 400,000 people within the European Union. Furthermore, as you can see here, for the various specific fields various technologies, among them the photonics, you can see that Europe is ahead than China and USA, and of course behind Japan. Just this figure is related to the number, to the share of European Union in terms of the patents in the photonics industry. Let me go further now with a specific application of photonics in fiber optic communications and present you some results from a paper, from a research conducted and from a paper presented a few months ago from the telecom sector of the Department of Electronic Engineering of the Mediterranean University. And I chose to present these research results that should be easier for the audience to understand. More specifically, the results are related to the so-called passive optical networks. In other words, it is the fiber to the home technology that is implemented throughout Europe in the last few years and will continue to be further implemented. More specifically, our research has to do with the so-called combo concept. That is the expected coexistence of various PON standards, various PON technologies on the same infrastructure that is implemented nowadays. To have a greater view of the whole situation, here are the latest results. They go back from September 2022. As far as I know, there are no more recent, the recent, because the Fiber to the Home Council, it's an alliance of European manufacturers, operators, and so on, which conducts and presents and publishes these results every September of each year. In any case, the results of the previous results of September 2022 show the evolution of fiber to the home or fiber to the building, homes passed in a number of countries around Europe, and not only European Union, because it includes also data from Turkey as well as former states of the former Soviet Union. As you can see, in the last 10 years, we have a tremendous increase of the evolution of this infrastructure, the so-called, as we will see later, the optical distribution network, which is the most cost-demanding factor for the implementation, for the deployment of these networks. That is the fiber itself and the associated infrastructure, because it is linked, this cost is linked with labor costs and not only with the fiber itself. This figure depicts how the adoption of this technology, the adoption by the subscribers of this technology. The same conclusion can be derived from this figure, that users to these countries mentioned before adopt more or less, but in a quite increasing trend, this technology, that is fiber to the home. The general architecture of PON technology is shown here, where we have, okay. Okay, thank you, Costa. Here you can see the coexistence of two PON technologies. The first technology implemented since 20 years ago, and now it is expected.
Δώστε μου ένα δευτερόλεπτο.
Ναι, φεύγω από το πλάνο. Αυτό.
Εμένα μου λέει φύγει από το πλάνο. Έτσι να κάνουμε. Δεν με βοηθάει.
Έχω ένα, εγώ δεν ξέρω αν παίζει, να το βάλω.
Όχι, δεν είναι αυτό. This pointer is like interlinked with the...
Και μέσα στο πρόγραμμα είναι και αυτό.
Δώστε μου δευτερόλεπτα, ευχαριστώ.
Τώρα παίζει. Ευχαριστώ πολύ.
Δοκιμάστε το.
Ευχαριστώ. Ευχαριστώ. Well, here you can imagine one of the so-called legacy PON technologies, and there are many of them that are based on standards of the International Telecommunication Union or the IEEE of the Institute of Electrical and Electronic Engineering. Here, for example, in Greece, we are talking about GPON, which is now implemented by the various telecom operators. And just a comment that I'm referring to the application of PON technology to homes and buildings, but the same standards are also starting to being used for the interconnection of base station sites for the mobile cellular networks, also for the data center interconnection that is actually the heart of internet as they host a variety of applications. But our results are focused here on the massive deployment of PON technology for home and enterprise users. Here you can see that we accommodate also the core, one of the most promising technologies, the 50 gigabit per second PON technology. Μήπως η μπαταρία έχει πρόβλημα? Δεν νομίζω. Well, here is by photonic module that is wavelength division multiplexing that couples and combines the infrastructure of the previous installed technology with the expected in the next few years 50 gigabits per second PON technology. Here is the field where by using optical splitters we distribute the optical signal to the individual subscribers in each home, in each enterprise, in each base station, as I mentioned before, and so on. And users may be subscribers of a legacy PON technology or in the near future of a 50% of a 50 gigabit PON network. But this between the interfaces you can see lies the optical distribution network, that is the deployment of fiber in the associated tubes and so on. Let's have a look at the wavelengths used for major ITU, International Telecommunication Union PON standards. The first one is the well-deployed all over the world GPON. You can see the downstream that is from the central office, from the telecommunication office to the subscribers, and the upstream rate from the subscriber to the network. Nowadays, most of the implementations of the deployments are related to next generation PON, where the downstream is around 10 gigabps. And the next evolution of next generation PON is that of next generation symmetric, where we would have 10 gigabits per second for both downstream and upstream directions. The focus of the research was the coexistence of next generation with the new entrant in standards, that of 50 gigabits per second, where you can see not only the data capacity in both downstream and upstream direction, but also at the last column you can see the wavelengths that are to be or are used, and for the 50 gigabit to be used. There are various combinations that can coexist. For example, as you can see, the wavelengths that are marked in red, these are wavelengths to be used and to be coexistent in the same infrastructure, in the same costly infrastructure. So, the combo PON concept has to do with the coexistence of various combinations, and more specifically, next generation PON with 50 gigabit. And this coexistence is an important evolution in the post 10 Gbps PON era. Here is the model we used for the stress test, I call it stress test examination of the coexistence of the two PON technologies, next generation PON and 50 gigabits PON. At the left side you can see the optical transmitters. On the right side you can see the implementation of the optical receivers by using the so-called direct detection. It's not necessary to go in details about what is direct detection, but in any case is a simple detection that takes into account only the amplitude of the optical signal level. Here are some examples of simulation results with various modeling options, for example by using pin or avalanche photodiodes for the optical receivers, that is for the receivers of the equipment we have in our home for receiving the optical signal, and as performance metrics we have the receiver Q factor and the BER, that is the bit error rate. Just keep in mind that as higher the Q value is, then that is the better, and as low the bit error rate is, of course, that is the better in terms of quality of service. Here is another set of results. On the left side you can see some main assumptions used for the modulation. In this example we compared the use of line coding scheme between non-return to zero and return to zero. Just keep in mind that the recommendations from the standard guide to non-return to zero, and it was also holds in this stress test conditions for our simulation model. Another set of results with various photonics choices as it related to the photodetectors, as you can see on the left side, and the gain of the avalanche photodiode 10, for example. And then the stress test continues for various fiber distances, that is the distance from the central, from the telecommunications office to the subscriber, from 20 to 50 kilometers, and we get values for Q and bit error rate metrics that, of course, are that deviate from the desired values. For example, we, in order to have an acceptable quality of service for the various e-services, Q should be more than 6. Most of what is happening and was shown by the results themselves is due to power depletion and crosstalk of the wavelengths used, as shown before, and these issues are due to stimulated Raman, mostly due to stimulated Raman scattering. As an extension of this work, a more realistic simulation could have been done and is actually actually studied now in order to incorporate digital signal processing as well as forward error correction algorithms to the simulation model presented before. And of course, various other combination scenarios, combo scenarios, could be tested, and not only that of 50 gigabit per second standard presented before. And many of these standards, already ratified standards, there are also other photonic technologies that support the so-called coherent pons and super pons for greater data rates for the provision of faster services, but it's out of scope of this presentation. The final, in any case, the final target is to fully exploit the most costly part of the whole implementation, that is of the optical distribution network from the telecom office to the users. Here you can see, just to see how things are working, that by the example of this standard examined before, 50 gigabits per second, that we have a loop of research, then we have component vendors, equipment vendors, operators to deploy the networks, in order users to have services, and then users and actually services demand more bandwidth, more stringent requirements from the network, and then a new cycle, a new loop of research in photonics, mostly in photonics, is required. For example, this 50 gigabit per second PON standard, which was initially ratified just 2 years ago for asymmetric operation, that is 50 gigabits only for downstream. Field trials and product announcements are projected in late of this year, with volume production starting next year. And the first implementations of 50 gigabits per second are expected, and of course, in relation to the business plans of the operators, 2 years later. Well, going further to the ATHENA Photonics Hub, the motivation is to include activities in various areas of photonics including, of course, fiber optic communications, in the whole vision of the ATHENA European University. More specifically, the Photonics Hub is due to Professor Petridis, who organizes some of the actions with other colleagues. In any case, this hub tries to bring together the photonics community within and beyond the European, the ATHENA Alliance, to boost scientific collaboration in photonics and to organize outreach activities for different audiences. For example, to design and deliver a joint module in laser physics fundamentals, which is a series of a number of asynchronous online lectures by various colleagues from the Hellenic Mediterranean University as well as from other universities of the ATHENA Alliance or outside the ATHENA Alliance, to organize COIL activities to related module with the Alliance, to organize invited talks by PhD students and postdoctoral fellows, as the one here, this talk from a colleague from France, related to fusion energy early this year. To inform, another objective is to inform the Alliance community of the research facilities in the field. You can see here a representative set of major research facilities as the Institute of Plasma Physics and Laser in our university, as well as other infrastructure or research groups in University of Siegen, Vigo, and so on. Another activity is to disseminate PhD opportunities and job vacancies in the field, and to support graduate courses and programs in photonics, such as the graduate course we have organized for 2 academic semesters. Here you can see just a screenshot of the optical networking module of the whole graduate course, where you can see the video captured lectures, as well as some simulation exercises for the students by using the software used for our research presented before. You can see the areas the main areas taught to our graduates in this course for data center networking, PON technologies, and for not shown here, for mobile network, for fiber optical network infrastructure in mobile networks. And let me finish the presentation. I'm not, of course, expert in this area of photonics. The interconnection between photonics and agro-food industry, where there exist various possibilities for examining various issues from a macroscopic level of covering phenomena that are spread around the globe till micron dimensions in various areas by exploiting photonics technologies. And for example, we could have precision agriculture which is now advocated as the preferred European Union response to two challenges. That of minimizing agricultural inputs whilst maximizing outputs for given conditions, for well-understood reasons, I suppose. And all these precision agriculture technologies and solutions include various technologies, specific technologies, such as geographic information systems, satellite image processing, drones, robotics, and sensors. All these agri-tech projects use or leverage photonics technologies. Photonics technologies are actually present at all stages of an advanced high-intensity farming value chain, from the inputs needed from primary production to packaging and cold storage, as well as food processing, distribution, and so on. Photonics can therefore help to supply safe, nutritious, and affordable food for all and establish a sustainable value chain from farm to fork by using ever more precise sensors and measuring devices. Farmers, food producers, food processors, and the ordinary consumers will be able to monitor and certify the safety, quality, content, and even the origin of the food supply chain. Thank you for your attention.
Questions? So I have something closer to... So first of all, the Photonics Hub, it was, like George has mentioned, is one of the initiatives of the Athena European University. We would like to show the principles that communities around a specific topic can collaborate in order to collaborate in all levels. Education, research, also contact with the community and vice versa, bringing the students that they would like to study photonics. This could be copied in all topics, like, for example, nutrition and dietetic sciences. My question is the following. My first question, what are the limiting factors in order all these optical networks to perform better? Do you need new materials? How to build the optical fibers? Do we need faster modulation of the laser sources, faster detectors? What are the limiting factors? And what is the vision? Like, where do we want to reach? Yeah, of course, of course.
And the network in Greece can support all this new technology that you provide now?
Let me start from the second question. Yes, at the moment. Yes, yes.
And
Yes.
be on the camera. Hey, George, it's better to be there. And because
this is the constraint, yeah. Well, of course, GPON technology is now implemented also in Greece as well as in whole Europe. This is the standard, PON standard. Most of the evolution that I showed in the first transparencies, the high increase of fiber to the home or building technology is based on these PON technologies. Among them, of course, in Greece. The research results with the coexistence of more than one technology, more specifically with the 50 gigabits, of course, as also mentioned, of course, there is not living 50 gigabits per second. They are expected around 2 years later. And also, I showed this the loop that involves component manufacturers, that is laser sources, modulators in order to to carry the information, the databits themselves that use the optical sources, the lasers. We have optical splitters, we have photodetectors by using also specific modules as shown in the simulation model, some of them. And then from these photonics, specific photonics devices, and I'm answering also at the same time now to your question, Kostas, then they come the equipment vendors. That is, for example, to be specific, Huawei, ZTE, Nokia, who use these photonics in order to construct specific equipment. And then it is the time of the telecom operators to use this equipment, actually, and of course, because except the technical point of view is the business point of view, that the operators base their plans on the expected market needs in order to diffuse the technology. Okay, and then arises the question when this technology, for example, will come. For example, 50 gigabit. Just a comment. Maybe when, for example, the Greek telecom operators decide to introduce the most probable, let's say, standard, the one presented here, more specifically, maybe we have additional standards with more advanced technology, such as the one of coherent PONs, coherent technology, and then we have the corresponding coherent PON. What coherent PONs will offer? Greater data rates, more speed, and more to cover, they can cover longer distances from the telecom offices to the subscribers. If you remember, normally the 50 gigabit per second PON covers is standardized, but it does not mean that we'll implement it in such a way for two differential distances, 20 kilometers and 40 kilometers. Newest technologies, and for example, not only coherent PONs means that we upload information not only on the amplitude of the optical signal, but at the phase also of the optical signal. In such a way, we can achieve greater data rates. But there is also another included in the transparency, SuperPON. SuperPON is not standardized by ITU or IEEE, but is an initiative from Google, who made some such implementation in USA. And what was the main initiative between this technology choice? To aggregate, to cover longer distances in order to aggregate telecom offices, that is to merge, to cover distances 50 kilometers. Fewer central offices, telecom offices means fewer cost, fewer personnel, and so on. Kostas?
Yeah, of course, this depends on the material of the optical.
Okay. Yes, for example, to achieve coherent is a
1.55 microns.
New wavelengths, to expand to new wavelengths.
Also, I have to use this. Thank you, John. The impact of photonics to our daily life is the 5G communication. 5G communications, they are so fast, and you can do even, you know, live surgeries, and the surgeries in the LA and you are in Austria, because of the capacities and the potential of how fast the signal travels and how fast the signal can be modulated because of the photonics, of optical signals. So now the signals, they are not the electrical signals, because the electrons, they have a mass, so they have an inertia, but photons, that they are inertial mass zero. So all these technologies are due to photons. I'm very much surprised, however, that when I saw the graphs, photonics in Europe and in the States are lower than other competitors. And I'm very surprised because Europe and the United States, they have flagship initiatives about photonics. So we have Photonics Europe and we have Photonics 21, which is like a national and European priorities in order to invest in photonics, in all topics, not only communications. In your area, it was Afiropoulos' presentation, how do they use optical spectroscopy in order to assess the quality of the nutrition, or the other guy yesterday in the States, the Professor Benos, if I remember well, he used optical signals as well in order to detect cancer or to treat cancer. There is another technique with the photodynamic therapy. So,
is there any limits to the photonic technology now, or we have done to the top?
There is a limit, the sky.
Yeah, but, yes, in general the sky is the limit, but even though we can calculate the sky in some way, is there any possibility with the same the photonic technology?
Well, the answer to this question is, but I'm not, I have not studied this topic. There exists, but you can search the optical Moore law.
Just a moment.
Yeah, I don't know if Kostas,
About
the
this,
optical.
This is a good point, but this is a completely different
Yes.
technology. The Moore's law, it was the law about the expansion of transistor that an integrated circuit can hold. With nanotechnology, with going from electronics to microelectronics, this capacity increased, which means that you can do faster calculations. Nowadays, the stringing of the dimensions and going to nanotechnology is a completely different story. So now we have saturation of the Moore's law. Now the Moore's law has been saturated. It has no impact. Now the technology has jumped to quantum devices, which is lasers is quantum devices, and to spintronics, which is a completely different story. So in my case, I would say to you there is no limit because technology is evolving and is trying to identify other ways of transportation of information, as my colleague has mentioned to you. This is one of the technologies. Quantum computing, for example, is operating based to spintronics. So there is no limit. I mean,
essentially no limit.
Because otherwise the progress and the science could stop.
We will be able to be the Star Trek one day.
I have an answer on this. There is Nobel Prize not now, in 1998, in 2002, that the Nobel Prize in Physics given to people that they did atom trapping. So what is the atom trapping? The atom trapping is using lasers and using lasers as tweezers, and they move one molecule from this position to this position. But like Star Trek, you could see the atom here and then the atom is there. So in molecular scale, Star Trek is there. And also there is another effort, like using laser pulses, using the electromagnetic pressure to send, satellites to the moon. So it's a matter of technology, how better lasers or more powerful lasers that we are going to use in order to increase the pressure. So I would like to give, and we should close here, that lasers have been invented as a device in 1960s. The first laser has been introduced by Hollywood in 1943 as a death race from Hollywood. So whatever is in Hollywood very soon becomes a reality. But Star Trek is there. So thank you very much, George, for this. I know George had the hardest slot. Because the people that after lunch they have the slots, I never predicted this. It was a new experience that I have. So thank you very much, George. Thank you. And thank you all of you that you stay until end. So we are going to renew our meeting tonight at 8:30 in the restaurant in Greta House. The dinner is offered by us. And I hope to see you, all of you. Otherwise, you will pay for your dinner. So this is not a clever investment. Thank you. Thank you also, Panagiotis.